Morning, everybody. It's such a pleasure to be with you. Thank you very much for having me. And just to say, if you'd rather be out there making snow people, I will understand. Norman was bleeding. He was in a plane that was being shot at. He was 6,000 meters in the air, and the plane caught fire. Norman got permission from the pilot, strapped on a parachute, picked up a fire extinguisher, climbed out onto the wing, and tried to put the fire out. As he was doing this, holding onto the front of the wing and spraying fire extinguisher at the fire, a fighter pilot came back, attacked the plane again. He was swept off the wing. With a burning parachute, he plunged 6,000 meters towards the ground. He broke his ankle on landing. He was captured. He was taken as a prisoner of war. He spent 10 months in hospital recovering from the burns he'd experienced. He was taken to a prisoner of war camp. He tried to escape. He was recaptured. He tried to escape again, successfully. At the end of the war, this is the Second World War, when his fellow crew members were finally released from the prisons they'd been held in, he was recognized with the highest award for bravery that exists for soldiers in the UK, the Victoria Cross. And as he went up to collect his medal from the king, the person next to him who outranked him and was getting the same medal said, "You should go first, you've been braver than I have." What's the bravest thing you've ever seen in your life? What does bravery look like to you? What does it look like to stand out and to be courageous? I work for the Campbell collaboration. I've been pondering the idea for a long time that there's another form of bravery that really matters. I'm calling it today bureaucratic bravery. What does it mean to be brave in a bureaucracy? What does it mean to be brave at work? What does it mean to be brave in the office? We have this idea of courage, which is often very physical, but there are other forms of courage that my experiences keep pushing me back to thinking about. So I want to tell you about 3 communities I've been involved in: the disability rights community, the fact-checking community, and now the evidence synthesis community. A few reflections on them that I hope may stimulate some thoughts for you. And this is a very rare opportunity at a conference where, when I finish talking, comments will be as welcome as questions. Disability rights is probably a community that's familiar to some of you. Its defining slogan is "Nothing about us without us." I used to work for a man called Colin Lowe. Colin is blind. He was president of Royal National Institute of Blind People. He was one of the disability rights commissioners. He was born with no sight. In the days when he was born, you either became a piano tuner or a lawyer, as he explained it to me. He ended up as a member of the House of Lords, which is an extraordinary thing, after being a leading light in the disability rights movement for much of his life in the UK and globally, and after teaching criminology for 20 years, including to Keir Starmer, who is now our Prime Minister. It was working with him and assisting him that I learned about the history of the disability rights movement. This idea of nothing about us without us. The people who'd gone from being kept in rooms where nobody valued their opinions and nobody thought that a disabled person could have an important opinion, to being kept in institutions where they were looked after but not listened to pioneering what was known as the independent living movement, to pioneering the mainstreaming of disabled people into education, to pioneering the social model of disability, which says that we are not disabled because we lack something other people we have. We are disabled by the assumptions society makes, such as the assumption that everybody can walk upstairs. All of these were revolutionary ideas at their time. And big institutions were created to look after disabled people by people who weren't disabled, institutions for disabled people. And over the last 50 years, 70 years now, it's been a large effort to transform them into organizations of disabled people. Colin was one of the first leaders of a disability organization who was actually disabled himself. It's an extraordinary thing. all of these important voices, and I worked with them in the House of Lords in a non-party political role, I should say, were told they had nothing useful to contribute for years and years. And yet they were some of the most inspiring people I have ever worked with, and they have changed the way we think. And anyone in school now, I had a conversation just yesterday, the nature of going to school if you have a disability has been transformed by decades and decades of struggle of people who refused to sit in the spot that other people thought they belonged in, and who believed they had a voice in a conversation that nobody else believed they had a voice in. And it's an amazing thing to travel all the way to London from far across the country on inaccessible trains, where you can't rely on access to a toilet, on access to a train, on access to anything, and chain yourself to the gates of Parliament. It's an amazing thing to do that. And that is what people had to do to make the case for disability rights in this country. Always leaves me wondering, what voices are we missing? What voices are we not noticing? What decisions are we making without the people who should be part of those decisions? The second community I want to talk about is the fact-checking community. I was involved in setting up the UK's independent fact-checking organisation, Full Fact. And in the earliest meetings of what became the International Fact-Checking Network, the International Fact-Checking Network is an extraordinary community, a global community of people all over the world who are tired of people talking rubbish about their lives and other people's lives, lying, misleading, being careless of the facts, and are pushing back. And in the UK, of course, we're very free to do that. In the UK, we can call out our politicians. I've repeatedly been in Parliament challenging inaccuracies and challenging the systems that allow inaccuracies to happen. In other countries, not so much. One of my abiding memories of the international fact-checking community is standing in the hall in Oslo where the Nobel Peace Prize is given out. The year before, one of our number, Maria Ressa, had won the Nobel Peace Prize, and the network had been nominated for the Nobel Peace Prize. You may know Maria's book, How to Stand Up to a Dictator. She ran the investigative journalism, or runs the investigative journalism and fact-checking organization Rappler in the Philippines. She has been repeatedly jailed. She has been repeatedly threatened. She has faced physical violence, and she has continued to stand up for the necessity of looking for really high quality information and sharing it and making our decisions based on the best information we have. I can't show you a picture of that room because our Iranian colleagues can't afford to appear on camera. They work in exile, and if their faces were seen, their lives would be at risk. So all over the world, there are people who are part of one community that believes in high quality analysis, that sticks its neck out for high quality analysis, and shows a certain kind of courage, physical in some places, moral in others. But they also depend on so many other actors in this space. And this is the thing about fact-checking. It's not really about the looking at a claim and working out whether it's true or not and sharing that, the act of journalism, which is the core of the fact-checking work. What it is about is looking at how does the false information come about, what enables it to come about, how do people succeed in misleading other people, and how can we change that? And when you start to trace that, you find that there are systems and processes that either make your work more friendly to good information or more friendly to people who would be careless or reckless or willfully misleading. And so in this country, I started working very closely with people who do analysis in government, with academics and others. And you realize the kind of pressures these people are under. I know for a fact that official statisticians in this country are regularly subjected to huge political pressure to ensure that the way statistics are presented is as supportive as possible of a politician's agenda in one direction or another. In other countries, that goes much further. Not very long ago in Montenegro, the national statistician was fired and had to fight a battle in the courts to be restored to her job after refusing to accept political interference in how the census was conducted. the National Statistician of Canada had to resign from their job to maintain the independence of their office. The director of the Bureau of Labor Statistics in the US recently was fired, as you may have read. In Argentina, the fight to maintain trustworthy inflation statistics has been a long and very hard-fought battle. Having trustworthy information depends on 1,000 quiet acts of integrity that happen in rooms that are often not seen, are often committed by people you've never heard of, who stand up for something, sometimes at the risk of their career, sometimes at the risk of their reputation, sometimes at the risk of jail. And that is repeated all over the world, wherever people are trying to do high-quality, trustworthy analysis that genuinely serves the public. That's an extraordinary thing, isn't it? That to work in the field of providing reliable information is somehow risky, but it is. The other thing I learned in the fact-checking world comes from an extraordinary exchange between one of the leaders of the Bank of England, which is responsible for setting things like interest rates in this country, and a regional group he went to visit, regional business people, charity leaders, and so on. And he said to them, I'm very glad to say that there is an economic recovery going on. And he said, well, that stopped in my tracks at that point because everybody looked at me and they said, what recovery? Whose recovery? There's no recovery here. People aren't gaining jobs. People aren't, our businesses aren't recovering and so on. But the national figures show the economy is growing, what's going on. And he went away and he looked at his analysis and he started to realize just how misleading looking at the aggregate picture of the country as a whole, the economy as a whole, is. And when you break it down by specific sectors, when you break it down by specific regions, it's perfectly possible to be able to say completely truthfully that the economy as a whole is growing, and yet for most people in the country, their real experience equally truthfully is that the economy is not growing. That was a revelation for him, and it's fundamentally changed the way I looked at our role as fact checkers. The tendency to look at, to smooth out the differences in what we look at is a very distorting way of looking at the world. And genuinely serving the whole public requires something more than an aggregate, an average view of the data. So now I come to the evidence synthesis community, which I joined 2 or 3 years ago. The Campbell collaboration, which I work for, is the body that seeks to support everybody who uses, funds, or produces evidence synthesis in public policy and social science. So they do systematic reviews of all of the evidence on big, important public policy questions and try to make that useful for people. Campbell has had a reputation for methodological rigor, possibly at the expense of usefulness. You could commission work, and 3 years later, you would get a perfect answer that you no longer needed and might possibly say further research is needed. That was the risk, but it would be very well done, whatever it was. Campbell took a very big risk in hiring me because I have no background in evidence synthesis, but they had committed in their strategy to being more global and being more used. The evidence synthesis community over the last couple of years has come together in a way that I hope will be of service to you. Firstly, we admitted we had a problem. We said publicly evidence synthesis should be faster, it should be cheaper, it should be better, and it can be all 3 of those things at the same time. And we set out 5 areas of improvement that would be necessary to do that. The use of AI, the use of data, user-focused approach, methodological and process improvements, and capacity sharing globally. Then we set out some big principles of how we wanted to do better. One was about harmonizing efforts globally, so there was less duplication and more collaboration. One was about equity in all of our work. The evidence synthesis movement, and most famous is Cochrane, is an amazing global community. But it has historically been dominated by the global north, by the US, by rich countries, Western Europe and so on. So we launched a global planning process. Fiona Campbell, who is here, is one of the leaders of that planning process and co-chaired the group on methods and process innovation. That planning process, for the first time in the history of that community, involved equal numbers of men and women in these important leadership roles, involved balanced representation from the global north and global south. Each group was co-led by a chair from the global north and a chair from the global south. It involved balanced reputation by different sectors and a whole range of other dimensions of equity. A very deliberate effort was made to bring together a new group of leaders to come up with a plan for how evidence synthesis could be faster and better and cheaper and ultimately serve people better. This 6-month process was painful. It was very high speed. It involved a group of people without previous relationships suddenly having to work together in high stakes decisions and make compromises and get along. But we came out of it and we produced a roadmap with a certain amount of blood and tears and a certain amount of smiles and joy. The roadmap sets out 5 steps to make evidence synthesis serve people better. And in particular, I think it's done a really important change, which is that whereas typically people had thought about evidence synthesis as something that needs to work directly with users, understand their needs, and then deliver a product to users, we started to recognize that you don't always need to be the people who own all of the relationships along the way to be useful. So there's much more emphasis now on the role of evidence intermediaries in how we make evidence synthesis useful. People who already have relationships with the decision makers for communities you're trying to serve, if we can serve them, we can serve all of the people they serve, rather than trying to build relationships directly with the public ourselves, directly with all policymakers ourselves, and so on. So that partnership thinking has been a really important change in perspective for evidence synthesis. So these are the 3 communities I've spent the last 20 years of my life in. Each of them in some way trying to change the world, each of them trying to take a big swing at the idea that we can be better off if we understand each other better and if we understand the world better. And here you are, trying to do the thing that's even harder than that. We have a saying in the fact-checking world, you cannot fact-check the future. And here you are, trying to figure out what the future looks like. I really respect that. Trying to do that well and fairly and ambitiously is an important public service. And so I come back to this question, what does it mean to be brave in that context? Dawn yesterday spoke about that being one of the values of your work, and I find it fascinating. It isn't planes on fire. But there is something, isn't there, about standing up for the facts when it's hard. There's something about not compromising being part of bureaucratic bravery, being that national statistician who stands up for the integrity of her work, even though she will lose her job. And there's something about compromising, something about being an august, decades-old organization that says, yeah, we don't think we have all the answers ourselves. We'll get in a room with other people and we'll work out what we can do together. And they didn't have to do that. And they lost some position from doing that in a way. People with reputations and careers and high dignity put themselves alongside other people with less of a reputation and less of a career and less prestige. They didn't have to do that, and it was quite an impressive thing to do. But bravery can't be both not compromising and compromising, can it? Maybe, maybe. I think what I increasingly come down to is this bravery, which sometimes manifests itself in standing up to dictators and sometimes manifests itself in very quiet rooms where you say no, minister, and sometimes manifests itself in the dark of night with a very large spreadsheet when you're asking yourself, do I really need to do that extra check on the data? Because the stuff you do when nobody's watching is actually what makes your work worth watching in the first place. All ultimately comes down to the desire to serve the public. And not just a bit of the public and not just the well-known bit of the public, but all of the public. The desire to recognize that there are people who are left out of the conversation who aren't being served and they need to be served just as much. And to stand alongside them and to agree. Nothing about us without us, nothing about you without you, because nothing about us without us is an empty slogan unless somebody else who doesn't have to agree with that stands alongside you and says nothing about you without you. So I just want to leave you with a thought and a question. one of the commitments the Innovation Observatory made in its new strategy, as we heard yesterday, was about developing new talent for the next generation of leaders. It's one of the commitments we've made in the evidence synthesis community too. And I think communities like this, which are strong at analysis, tend to be really good at developing analysts. We're really good at teaching technical skills. We're really good at saying, that's what good looks like. How do we get good at teaching bravery? How do we get good at teaching what it means to be a leader? How do we make sure we develop the generation of people who won't just reach the top of their technical skills and then find they don't have the skills to get into the next room where they can really influence senior decision makers who don't understand their technical skills? And if we develop those people, how do we make sure they have the damned integrity to stand up and make that analysis count and make it matter, make the compromises that you have to make in rooms like that and do it with integrity? How are we developing those kinds of leaders? So I've been talking with friends about this idea of bureaucratic bravery a little bit recently. And two separate people, one who's worked in a giant global company that shapes our day-to-day experiences, and one who's worked in a frontline public service role, both said to me, we need heroes. We need to have the myth of what it looks like to be brave, the heroism of what it looks like to stand up with integrity. And we have those kinds of heroes when we think about the past. This is, for those of you who don't know, Millicent Forsyth, a leader of the women's rights, voting rights movement in the UK, or one of them. We have those leaders when we think about wartime. How do we identify and celebrate the heroism of bureaucratic bravery? How do we celebrate the integrity that comes with that kind of work? So that's my final question to you. Who are your heroes? What's the bravest thing you've ever seen them done? And have you told them how much you appreciate them? Thank you very much for your time. Your comments, please. Thank you.
Hi there. My name's Claire Bennett. I'm Associate Director for Research, Knowledge and Design for Health Innovation West Midlands. Previously, I was co-director for the Wales Centre for Evidence-Based Care. So we did a lot of evidence synthesis there, and I'm bringing that into my current work. I'm really interested in what you were saying about speed. And I think when we're thinking about systematic review and the comprehensive nature of systematic review, I'm still getting stuck on the speed of searching, the speed of sifting and so on. Have you got any tips
Yes.
that you can share?
Very surely. I mean, Fiona actually is an expert in evidence synthesis, and I'm just the support staff. So let me say, if you want a proper conversation about how to do this, Fiona is your woman. But what we think is there's far too much in evidence synthesis of very highly qualified people doing grunt work, repetitive tasks that require their skills, but are nonetheless repetitive and not a particularly fulfilling use of those skills. So the question is, how do we decrease that? And we think there's two answers. One is sharing the workload, and the other is technology. So we know now that AI can do a very good job of screening, speeding up the screening process, prioritizing what records need to be screened, and so on. And you'll see that being more and more normalized in the next couple of years as the evidence synthesis infrastructure collaborative technology stack becomes widely used. But we also know that people routinely extract the same data from the same studies in different places, which is crazy because it's a boring and thankless task. So if we could do it once for everybody, we'd be much better off. And that's what we're trying to do, build those shared repositories that can make, many hands make light works. So we will be developing repositories at Campbell in 4 areas so far, which are crime and justice, sustainable development, education, and climate, environment, and society, which the extracted data that they had collected so that other people can reuse it. At ESSEC, collectively, we're going to be building out sector hubs across all sectors to enable those kinds of shared repositories of information and to enable sharing of technology to speed up this work. So I'd really encourage you to follow the work we're doing at ESSEC. And although it's currently a roadmap and not a reality, it's a roadmap which is very aggressively being turned into a reality. And I think in the next 1 to 2 years, you will see day-to-day changes in your workflow. There's a hand up.
Thank you for that. That was very, very interesting. I used to work for NICE, and we had regular submissions from pharmaceutical companies.
Sorry, could you speak up a bit?
Yeah, sorry. Can you hear me okay?
Yeah, just about.
Yep. I used to work for NICE, and we dealt with a lot of pharmaceutical company submissions where there's obviously that commercial pressure to make the data show the information that you would like it to show. Any kind of comment on how you can cope with the commercial how can you show bureaucratic bravery in a commercial setting?
Yeah, it's a really good point, actually. And I thank you for bringing it up, because it's somewhat similar pressures, but even less thanks. And I think there's two parts of it. One is we need individuals with integrity, and we need to recognize that need. We need to train people for it, and we need to celebrate it. But individuals with integrity only work when they have structural support around them. So, for example, in the official statistics system, there are fundamental principles of official statistics set out at the UN level. And then many countries around the world have now statutory protection for those principles. In the UK, we have something called the UK Statistics Authority, which oversees the integrity of official statistics. You've got an escape valve. You've got the professional body, the Royal Statistical Society, who you can ring up and say, I've got an ethical dilemma. How can I, who can I talk to about this? How do I get advice? So as well as needing to develop people, we also need to create supporting structures around that. My question in a corporate sphere would be, can you create structures inside the company that promote that kind of thing? The equivalent of a chief, analyst or whatever, whose job is to protect the integrity of work. Are there external safety valves that can also be linked into, which might be professional bodies or something? But we cannot realistically expect this just to come down to individuals being willing to sacrifice everything on, every last dot and comma. So I think you need the combination of the institutional support and the individual integrity. Anybody else?
Who's your hero?
I mean, I'm very, very fortunate with the people I've worked with. But when Lord Lowe and I were wandering around Parliament, the joke used to be 2 eyes and 3 ears between us. And having sort of hearing on one side and partial hearing loss on the other, I can function in most rooms, so I've never really thought of myself as disabled. And then suddenly I sort of happened to get a job in that context, and it really changed the way I think. And it made me realize how important it is to stand up with the group when you can, if you see what I mean. And I had a long conversation with a friend of mine who's a guide dog user about, should I say I'm disabled? And he said ultimately that yes, you should, because if the people who can opt out don't opt in, then the group is smaller and weaker. So to come back to your question, Colin Lowe, absolutely. I had the great privilege of working for one of my heroes. And the reason is, when he was on the Disability Rights Commission, he's an expert in special educational needs. He argued that mainstreaming every disabled child into mainstream schools was a bad idea, that mainstreaming is important, but it's not right for every kid. At that time, mainstreaming was the thing that everybody believed in. And he got chased off the Disability Rights Commission as a result of standing up for what he thought was right for children. Ended up in the House of Lords, so he did a right out of that. And the person who chased him off the Disability Rights Commission also ended up there. Jane Campbell, who some of you may know, social care expert, is now a 24-hour oxygen user. The first person allowed onto the House of Lords with an assistant because she can't read her own speeches end to end because she doesn't have enough breath to do it. Sue Masson, Baroness Masson, once told me, I hope it's okay to say on the record, that repeatedly when she was in hospital and she was regularly readmitted to hospital, they would put do not resuscitate orders on her because doctors could not believe that her life was worth living. And we wonder how we're going to involve people in analysis, in horizon scanning, in foresight, in synthesis or anything else when people just assume your life isn't worth living. So, yeah, I have heroes, but it's the group, not the individual. You know, that collection of people who stood up for disability rights in the House of Lords. Jack Ashley was another example, very famous for his work on the thalidomide scandal. There was an extraordinary collection of people who had each other's back there, who have very different experiences, blindness, wheelchair user, deafness, etc., but who shared principles, who had very serious conflicts between them, but still stood up for something together. And I think if a team can be your hero, that team. And that seems like a good place to end it. So thank you all very much.
I think that was an absolutely extraordinary keynote. Thank you all. That was, yeah, certainly given me a huge amount to think about. So we're going to move on now to the first of the oral presentations of today. And our overall theme is going to be exploring cutting-edge methodologies in horizon scanning, foresight and futures. And if I could welcome to the stage our first speaker, who's going to be Farnaz. Big round of applause. Come on, let's be nice and encouraging. There we go.
So, good morning, everybody. Such a difficult act to follow after that keynote. And I'm actually going to perhaps shock you with a really fast barrage of slides. First, I would like to explain why the reason is I come from a different discipline, and I'm going to share a lot of stuff with you to hopefully give you an idea of what we do and if there is anything in there that might strike a chord. So the talk is called Advancing and Disentangling Patient and Public Involvement and Engagement through Design-Led Innovation Methodologies, and a framework that we call ICARE. I'm Farnaz Nickpour. I'm a reader in inclusive design and human-centered innovation. So by now you have gathered that I'm not a healthcare professional. I also direct a design research lab, which is called the Inclusionaries Lab for Design Research, and that's why I'm here in the room, because a lot of the work that we do is very much at the intersection of healthcare and mobility. Our core areas of expertise as a design research lab is around inclusive design, human-centered design, systemic design, and design futuring, mainly in the area of healthcare and mobility. And we have kind of 4 key themes around design for healthcare innovation, inclusive mobility, design for palliative and end-of-life care, and also psychosocial inclusion. I just wanted to give you a bit of an idea about the range of design projects we work on, which is really goes from design of health products to health services and health systems. The first one, inclusive medtech design, I'm going to talk about it in the presentation. Also, the one around systematic improving systems of health and social care for MLTC, people living in multiple long-term conditions. But at the same time, we also look at the idea of taking design outside the School of Engineering and Faculty of Science and Engineering. So I'm part of a team where I lead teaching design to the future workforce. So I've been teaching design to year 3 MBCHB students at the School of Medicine, thinking about how can we take the idea of design, innovation, and entrepreneurship to the future workforce. So the structure of the talk is going to be, first of all, talking about what is a design-led approach to PPIE, which is 2 dimensions, disentanglement and advancing. What is design? When everybody designs, and design has become a very ubiquitous kind of term. And then I'm going to share very fast 2 examples of how we have used design-led innovation in PPIE in terms of health systems and health development. The first project is systematic, funded by NIHR, which, as I mentioned, looks into improving systems of health and care. And the second one is Elevix, which is design of an inclusive medtech piece for children and young people living with progressive neuromuscular conditions, specifically DMD and SMA. And then I will very briefly share the ICARE framework, so I will wish myself luck. So I'll start by talking a little bit about the idea of disentangling patient and public. And these are some excerpts that I have provided from a piece that we published conducting a systematic mapping review of design contributions in oral health. But we have done a number of systematic mapping reviews around design contributions to palliative and end-of-life care, to mobility, and to oral health. And the results are, some aspects of it are common. So first of all, adopting a design approach, we distinguish and separate patient and public because from a human-centered design point of view, there exists a major distinction. So what is human-centered design? Human-centered design centers the needs, requirements, and desires of people. Like we really focus and kind of position it at the center of the process, and we draw two distinctions. So we work with two distinct groups of people. Either you're working with what we call the end users. These are people who have got experiential knowledge of that topic, and they interact with that situation, topic, again, product, service, system directly. And then stakeholders who might have, they might be affected by the topic, and they might have an interest in the topic. So these two distinct groups there are different purposes and different methods for engagement with them. And the same, similar to end users and stakeholders, patient and public, there are distinct kind of purposes and approaches to be used. It's interesting when we were doing the review to see there are calls from within the healthcare field who are also asking for this disentanglement and kind of moving beyond the tokenism. Again, what we found was that different kind of authors unpack distinction in different ways, but the key differences were in elements of impartiality, experiential knowledge, interest, perspectives, and expectations. And one way or another, the call was to actually separate them. I just want to draw a very quick parallel to BAME and how gov.uk since 2022 has stopped using the term black and minority ethnics. This is actually something I've taken from gov.uk website, and I just wonder, as we go further into PPI, PPIE, PPIEP, whether there might be a point where we might see for the very important points of not being exclusive, not averaging out, or masking lack of representation, we might want to move towards disentanglement. So our suggestion is that it might be worth making clear distinction mainly around the questions of who to involve and how best to involve them in terms of patient and public involvement. So I'll quickly move to the advancing part beyond the kind of disentanglement part. So from a design point of view, we offer a combinatory set of participatory, creative and generative sense-making and kind of visualize and materials approaches. And this is really based on a combination of a different range of, I would say, disciplines in design: inclusive design, human-centered design, systemic design, and participatory design. And I think it's important to mention that participatory design, it incorporates co-design, and co-design is a subset, quite challenging, idealistic, and extremely resource-intensive subset of participatory design. I think at this point it might be useful for me to very quickly run you through a definition and why a clear definition of design matters when everybody designs, and design is really everywhere. We define design on three orders, and we think it's really important to start with the point of epistemology rather than jumping into methods. So we look at design as a professional discipline that uses a set of knowledge, methodologies, mindsets. So we look at design as epistemology. We also look at design praxeology. So this is where we look at design as a process of problem framing, but most importantly and firstly problem solving. And then we look at a set of processes, methods, tool, and finally we look at design ontology in terms of design outcomes. So I think the three aspects of when you engage with design, we're talking about design ways of knowing, design ways of doing, and design outcomes. And this is a framework that I have shared from a piece study published in BDJ, where we actually talked about this meeting of design and health beyond the point of interventional contributions that design could do, where we talk about the 4 orders. So you could look at design of a piece of communication, and there are some examples there, whether it's a patient leaflet, to you look at the order of designing a product, designing a service, or designing a system. But beyond the interventional contributions that design could offer, we also talk about the theoretical, the methodological, and the empirical contributions that a design approach could offer. And through a really fast move from this point onwards, I want to give you an idea and some examples of how we might be using design in those capacities for kind of methodological and theoretical contributions. So the argument around the value of design-led approach in this involvement is moving from kind of descriptive analysis to actionable insight, kind of moving towards more generative and creative approaches of working with people, from describing to visualizing and modeling, and making sure that we're actually offering a kind of inclusive and diverse set of participation. I have underlined this because I'm hoping that some of this might come through as I take you through some examples. And I will need to run through it very fast, so I do apologize, but I hope it makes a bit of sense. This is the ICARE framework, where we talk about 5 core dimensions that a design approach might offer: inclusivity, creativity and generative approach, accessibility and flexibility, responsibility and equitability. So the first example I want to share is about from the systematic project. If you scan the QR code, throughout the talk I have provided a few different QR codes that I hope would provide lots of kind of information if you need it. We have developed a digital commons, which was inspired by Turing Commons for the project. This was an NIHR and EPSRC funded project looking into improving systems of health and social care for MLTC. And I would not be able to provide as much detail as I would want. So earlier this year, we were invited by Alan Turing Institute to run a seminar to summarize our approach to this project called Designing with People, Systems and Data in Health. Again, the QR code will take you to the webpage, where there is a recording of the presentation as well. And we really introduced a 3-tier model of person, journey, and system maps for MLTC there. The project looked at an approach of bringing people, data, and systems together. So we looked at health intelligence, 3 units that would work in parallel: health intelligence, people insights, and system science. And this was the 3 groups that were kind of like working alongside. I would not be able to take you through the whole process. So as you will see, we had 3 groups: people insight group, systems futures group, where we talked about 3 orders of going from systems optimization to system innovation and system transition, and then how can we bring data. And we were focusing on 3 different key groups: pre-frailty, working age, and complex lives. I'm going to share very briefly some of the work we did in terms of people insights group. And we developed an activity book, which was informed by what is called design probes or culture probes. We worked very closely with our public advisors and people of lived experience to develop it through multiple stages. The data collection throughout the whole project was very much informed by an inclusive and creative set of methods that we used for both engaging with people of lived experience, but also bringing in insights from other stakeholders, for example, whether it was health and care system or whether it was VCFSE. And as you can see, we went through elements of co-production to collection and synthesis and then validation. This is the bit I would like to briefly run you through, but I'm running out of time. It was a 3-tier person journey system model, which allowed us to, first of all, move from personas to person maps. to develop journey maps, which took us from this model approach or understanding of journey of multiple health conditions to realities of journeys of health conditions, allowing us to create a template based on which we were able to collect data from people. And these, the combination of journey maps and person maps, were found really useful by GPs as well as patients, saying, this would be really interesting if I could incorporate an element of this into the electronic patient records. LVX project, which is around the design of inclusive medtech for Duchenne muscular dystrophy and spinal muscular atrophy. This is a kind of cross-sector collaboration which has been funded by PPL Green Fund as well as IUK KTP. Again, there's a lot to cover around the project. There are two aspects that I would like to share with you, with the audience in the room. First of all is moving beyond or combining the concepts of patient acceptability and user desirability. This is I think there are, and the whole argument is that if we really are looking at sustained patient engagement, especially in cases of chronic disease or prevention, patient acceptability is absolutely essential, but insufficient, because at the end of the day, patients are also users, and continued participation really requires going kind of beyond good enough to want to use. We have also done a lot of work around not only capturing requirements, but capturing narratives and how narratives of a design would, from where the narratives come, it would impact the design of a product or service. We have developed a typology of narratives. Whose narrative is it? Is it experiential narrative, societal or disciplinary, and is it a dominant, alternative or counter narrative? In LVX project, we have collected these narratives, and we have thought about how could we embed these narratives. So to remind ourselves again of the 5 principles of ICARE framework, I haven't had time to actually talk about how we developed the framework and embedded it through the project, but I think the whole idea is that adopting a design-led approach would allow us to better use this. Thank you so much, and I would be more than happy to answer any questions after this. Thank you.
Super, thank you, Farnaz. So if anybody does have any questions, come and find Farnaz in the tea break. That's a new one. No problem. That's all right. Fabulous. If you could join me in giving a big, warm welcome to the stage to Dora.
Thank you. Morning, everyone. My name is Dora. I work for the NHR Research Support Service Hub in Newcastle, just here in Bedley Clark, and I'm the EDI methodologist. So my work sits kind of in the intersection of EDI, research inclusion, and specifically my research area is LGBT aging. So that's what I'm going to focus mostly on today. And I want to explore how integrating EDI into Foresight practices can reshape how we anticipate future health needs, especially for LGBTQ+ communities, but also I think it's applicable to other marginalized groups. So my argument is, rather than treating equality and EDI as kind of an add-on and an afterthought, it should act both as a lens and a disruptor that strengthens the validity, robustness, and policy relevance of health research futures. So horizon scanning and future planning are increasingly important. We know that for UK health research, for health research overall. They help us, well, both us, funders, policymakers, to identify emerging trends, diseases, technologies, and population shifts. However, there's a key challenge that remains in horizon scanning, and that's also kind of, as Will mentioned, whose voices are left out, whose narratives are not being heard. So how can future-oriented research be more equitable in the data, the voices, and the experience of marginalized groups that are missing from the evidence base? I'll talk about intersectionality, and I'll offer a definition of it further down the line. But if we look at the LGBTQ+ community, particularly people who are at the intersections of age, disability, ethnicity, class, and migration, they remain underrepresented in data sets, surveys, and clinical research. This absence doesn't simply reflect a lack of information, so the information might be there, but it creates distorted futures where structural inequalities are reproduced rather than reduced. My aim today, as I said, is to show how EDI can serve as an anticipatory tool, helping us notice those early signs of exclusion and to respond proactively. So horizon scanning, as we know, usually includes 3 steps: identifying weak signals of change, clustering them into trends, and interpreting their implications for research and policy. So if we look at the NHR, they use horizon scanning to determine research priorities, funding strategies, national policies, agendas, and so on. But the emphasis often falls on biomedical innovations, economic drivers, technological breakthroughs, kind of dismissing social inequalities, lived experiences, and community-driven knowledge. But on the other hand, as I'll mention later, NHR does include research inclusion in its kind of core work, so there's 2 sides of it. The result of the kind of erasure and the invisibility of these narratives is a Foresight system that can predict the emergence of new diagnostic tools, but may fail to anticipate the deepening of health disparities for groups that are already historically marginalized. If we focus on the LGBTQ+ population, we know that they face systemic inequalities. They have higher rates of mental health diseases and issues in relation to their heterosexual peers. They often face barriers to primary care, as well as social care, healthcare. They have lower satisfaction with services, and they often suffer from minority stress trauma due to the lifelong discrimination that impacts their overall health and well-being. And if we look at the intersection of age, sexuality, gender identity, this is really prominent in those groups. Despite this, all of these issues that we know are there from research, they rarely appear in Foresight literature because they're not easily captured by standard data sets or systems. So the data is not collected. I think I did some work in social care at the University of Birmingham, and we had information that out of 104 NHS kind of health data sets, only 28 collected information on sexual orientation and only 4 collected information on gender identity. And then, people respond not sure or prefer not to respond, and they just get bunched into this homogeneous group of other. Intersectional inequalities also magnify risk. So, for example, LGBTQ+ people of color, again, older LGBTQ+ adults and trans individuals are at most risk of compounded barriers that often remain invisible in quantitative data sets. And then this creates an equality gap, a mismatch between the health challenges that actually affect marginalized populations and the challenges that are formally recognized in future analyses. So how can we use EDI to intervene? First, as a lens, EDI allows us to critically question the assumptions that shape Foresight, so who is included in evidence gathering, whose needs are prioritized, and which types of knowledge are considered legitimate. And then, on the other hand, we can use it as a disruptor to introduce new ways of noticing. So it can foreground experiences such as stigma, exclusion, or trauma, and the disruption is productive, so it's not disruptive, even though it is a disruption, but it's productive because it widens our understanding of what counts as a future health issue, ensuring that future planning doesn't replicate the injustices that have already existed. So how do we embed EDI into horizon scanning? We can begin by asking explicitly inclusive research questions, defining whose futures are being explored, and ensuring marginalized populations are not an afterthought. We can then broaden the evidence base beyond conventional literature, which means including community reports, qualitative studies, grey literature, advocacy publications, social media conversations, and also lived experience. So co-production is key. When identifying patterns, we need to consider how emerging signals may disproportionately impact different groups. And then we can apply an intersectional lens to understand how sexuality, gender, age, ethnicity, and disability interact, among other kind of protected characteristics and other diversity characteristics, to produce varying forms of vulnerability and resilience. Finally, we can translate Foresight findings into actionable strategies, again co-developed with affected communities. This will ensure future policy recommendations that are grounded in lived realities and not kind of in abstract predictions. To give you some practical examples and case studies, we have the National LGBT Survey from 2018, which revealed substantial unmet healthcare needs for the LGBT plus population in the UK, particularly for the trans community. But despite these clear indicators, there's still a strain on health systems and gender services even now. So this was 7 years ago. Right now, we have the LGBT plus health evidence, which is currently evidence review, which is currently underway. So this also will contain signals for future health inequalities, which will require structural interventions in the present. As I mentioned, kind of NHR, in the Include framework, it provides a structured approach to improving research inclusion, but most horizon scanning projects still don't incorporate these principles. And finally, in my own kind of area of LGBTQ plus aging research, we see how historical exclusion can reverberate across the life course. Older LGBTQ plus adults often have different support needs, might not have access to formal care, rely very much on their family and friends, and that has implications for social care planning, dementia services. There's almost no research about older LGBTQ plus people and dementia, so the intersectionality of the two is still very much under-researched. All of these examples highlight, I think, the same point, that early indicators of inequalities are visible, but Foresight frameworks often fail to interpret them as future health risks. I talked about intersectionality, and I kind of realized that I should have maybe put this slide somewhere at the beginning to explain what intersectionality is. So it is a concept that shows inequalities, it shows kind of our lived characteristics, and then how the combination of those characteristics creates privilege or discrimination. This illustration is by Kimberly Crenshaw, who coined the term intersectionality based on her research on Black women who she understood were doubly marginalized. So while there were laws for Black men, protecting Black men, and there were laws for white women, there weren't any kind of legal framework protecting Black women. So she saw Black women as at risk of discrimination much more than either of these separate groups. We have 12 kind of characteristics here, and there's many more. If you just think about your own, identity and how you understand yourself, I'm sure every one of us can find at least a dozen more characteristics that define us. So it's the compounded effect of these characteristics that create privileges and discrimination for us. So why is intersectionality important in Foresight and horizon scanning? Because it doesn't predict just generic trends, but it anticipates impacts that help us prepare more inclusive responses. So for example, we heard yesterday about kind of access to digital health in rural Scotland. So, a technological shift like digital triage might help populations improve access, but if you have a community that doesn't have regular access to the internet or is technologically illiterate, it can exclude populations who live in very remote areas. So we need to kind of look at all those intersecting identities to understand what inequalities are coming down the line. So practical applications, we can expand data sources, as I mentioned, kind of moving beyond traditional data sets and peer-reviewed literature to include more of that gray literature, community-produced evidence, surveys, grassroots reports, and so on. We can use participatory foresight to involve co-production scenarios with stakeholders. We can imagining the futures with them, not just for them. And involving them into those conversations. Then we can anticipate inequality, so treat exclusion itself as a measurable risk factor, not just, as I said again, as an afterthought or kind of, oh, this is happening, we had no idea this would be a problem. And finally, we can reimagine progress by reframing inclusion not as an ethical add-on, but as central to innovation and system resilience. So these four approaches together can position EDI as a methodological innovation and one that makes our foresight practices more rigorous, responsive, and aligned with the realities of contemporary health inequalities. And if we talk about, the core principles of NIHR, this is playing into that, better health outcomes for all. Finally, just a couple of messages to leave you with. EDI strengthens the accuracy, ethics, and robustness of horizon scanning in health research. Intersectional foresight helps us anticipate inequalities before they can become entrenched. And EDI is not a constraint, so it's a catalyst for innovation, allowing us to imagine and build healthier futures that include everyone. And as we heard yesterday in Dawn's keynote in the morning, horizon scanning needs to share insight, challenge assumption, and embrace diversity. And if we understand foresight as anticipating change, then I believe EDI must guide how we prepare for it. Thank you.
We've got time for a couple of questions. We've got about 2 minutes. Does anybody have any questions for Dora? You need to be quicker. Cool, I think you've answered everyone's questions. Great, thank you very much. It's always nice when that happens. So if anybody does have any questions for Dora, please come and find it in the break. So just before we move on to our final speaker for this particular session, I should have mentioned at the start and again forgot, so forgive me. There are prizes, excitingly, for the best oral presentation, lightning talk and poster. So as we're going along today, do make notes and there will be voting at the end of today, so please do make notes as we go. So for our final speaker of today's session, please welcome to the stage Joshua.
Yeah, so I'll start. So I'm Joshua Bracewell. I'm a health service researcher, part of Healthcare Improvement Scotland. If you find that upsetting, I can only assume that you're Danish, and I can only offer you condolences on losing the other night. But essentially that theme of punching above our weight is really, a Scottish theme, and it is prevalent in Anya as well. Or obviously, like me and Scott McTominay, you can be imported from Lancashire. So looking at the contents, we're going to quickly talk about what is Anya, sort of the context behind what we're doing, have a bit look at the processes, and I'll give you some insights what we found so far. It's obviously quite a lot, but we'll try and keep to time. So first of all, Anya is the Accelerated National Innovation Adoption Pathway. It basically seeks to bring innovative technologies in a once for Scotland approach. We'll come on to sort of why that is a problem later, and it involves a number of special boards in NHS Scotland, including us as Health and Care Improvement Scotland. We're sort of responsible for the evidence aspects of it, and we're under the governance of the IDA, which is basically a lot of senior Scottish Government and NHS leadership, and is chaired by Anna Dimacek, who's the Chief Science Officer, and Tom Steele, who's the head of the paramedic service. So today we're going to mainly focus on horizon scanning, which is what brings in the technologies that can then feed through this process right up to implementation and benefits realization. So just a quick example of a few technologies that have been implemented in Scotland. We have the digital dermatology pathway, and we've got the type 2 diabetes program, and a couple of pharmacogenetic programs that look for clopidogrel and gentamicin resistance. So that's sort of what Anya is in a nutshell, and now we'll look a bit more into the context. So I've got to thank Sonia and Andrew for letting me vandalise their framework, but essentially this is just a nice linear representation of medtech development, and obviously, as we know, it really doesn't work like that. So just to point out, that is why I've left clinical trials empty, because it does not have the requirement of the phase 1 to 4 for medicines, and you find a lot of these technologies in NHS a lot earlier than you expect in medicines, and if they do get this regulatory approval, it's a bit of a free-for-all what sort of happens. So trying to map where we're looking, Anya itself sort of looks at this imminent horizon of established technologies. If you work in technology readiness level, I'd say this is probably like an 8 or a 9, but innovation in Scotland is supported across the entire pathway, so we have Scotland Innovates and the innovation hubs, and then we've tried to, for illustrative purposes, sort of map some different processes and organisations, but obviously they tend to move and how they'd work tends to change. So now that's sort of a bit the problem why and what we're trying to do. We're trying to bring this once from Scotland approach, which isn't really there for medtech at the moment. Obviously, we're quite pragmatic and small scale, but we can come on to that. So looking at sort of how we do this, I do a horizon. Wow, that is really tiny. That did not look that tiny before. So the horizon scan is done every 3 to 4 months by the health service researcher, is me. I'm the only one that's paid to do this, basically, so that's why it's quite pragmatic. I'll look at a range of desk-based, and I'll firstly look at desk-based sources, if you can even possibly imagine what that says. And basically, this is me looking at a lot of HTA websites, which I'll show about later, and a bit of limited literature searching, but because it's only me, it's kind of like resource constrained. And the other side of the aspect is more of like the reactive model. So I have these connections within Scotland, so that's Scotland Innovates and Innovation Hubs that I spoke about before. And obviously we get a lot of direct referrals from clinicians and such that will come to me, or the Centre for Sustainable Delivery, and they are one of our partners. And then obviously I've got some more wider UK contacts with the NHS Innovation Service and trying to build up relationships with NICE and HTW. So if anyone from NICE wants to say hello, please do. And obviously we do meet with the Innovation Observatory. But essentially I left a lot of empty hexagons here because this contact list is always growing. It's not restricted to that. And from this, I'd say I'd get around 50 to 70 technologies every quarter or trimester. And essentially this is where I'd say sort of a traditional sort of stance on horizon scanning ends, and it's sort of where we sort of move mainly more into topic selection. So from that list of 50 to 70 technologies, I'll assess them against our 3 criteria that I'll come onto in a moment. If it's positive for all 3 criteria, it's marked as an amber technology, and then if it's not, then it's marked as red, and we'll come on to what we do with those later. So this is a bit of a busy slide, but essentially the 3 criteria. First one is ANYA suitability. That mainly means, does it have regulatory approval? Is it available for procurement? Has it been used in NHS Scotland or any NHS system? And is it an innovation? Evidence of benefit, I did pick up yesterday, this was mentioned as well, is a really hard topic because medtech does not work the same as medicines. So I like to think of it as based on risk. So for instance, if I've had a digital consent tool which had an evaluation sort of level of evidence which would be sufficient for that, but then if you have a cancer technology, then you expect the higher systematic review RCT evidence. But it is a really hard one to nail down, and it can be a bit subjective. And then lastly, we have importance to NHS Scotland, because we're only looking for the topics that affect the most number of people, because we're such a small funding body. And we look at how much of a benefit is over current system, and then how does it fit with the Scottish priority documents. So there's about 3 of them published this year, and essentially that's basically the common things are like person-centric care, moving away from secondary into primary, etc. So from that technology list, so that's 50 to 70 technologies, I'd say about 12 to 15 of them marked as amber after the filtering, and this is checked internally. And this goes to our first shortlisted meeting, which involves in various clinical and operational expertise across NHS Scotland, so the innovation hubs and some clinical leads and such. And obviously I'll present these and we'll discuss them, and a few of them, probably about 4 or 5, will be marked as green. And I basically prepare this innovation briefing, which is a 2-page document. So it's a bit more information, but it's still highly pragmatic and quite high-level information. And this is checked again at the second shortlisting meeting, and this is then presented to the IDA, which is the governance body, to be considered for selection for the next stage, which would be a strategic case, and you get a lot more information out of that. So obviously that's sort of our processes, which I guess are quite different to a lot of places, and now I can sort of give you some insights on what we've seen so far. So from around May 2024 to April 2025, we identified 269 unique technologies. Obviously, a lot of them aren't ready for assessment because there's no evidence. There's no evidence for them yet, or a lot of times, if it's like a NICE or a Welsh document, the guidance is still in development. So obviously, there's nothing to say. And you assess these. You assess them against the criteria. A lot of them don't meet the criteria, or actually, some of them actually already assessed by us or ANYA. And then they follow through that shortlisting process right up to the IDA. So the main point I want to also take away from this is that all this red isn't lost. So all these technologies are stored on a database I built in Nested Knowledge, and essentially any technology can and a lot of them have come back through the process with any significant update, or I chase leads and find out more information. And so it can also just filter back through. Once again, this is awfully small, and it wasn't meant to be that small. But essentially, I was trying to give some updated results from so now there's about 390 technologies, and the main areas you see technologies are, well, the most number of hits are in cancer, cardiovascular, musculoskeletal and neurodegeneration, and these loosely match the leading burdens of disease in Scotland, being cancer, cardiovascular, but another leading cause of burden of disease in Scotland is substance abuse, and I know it might come under that mental behavioural disorders, but I've never seen any technology that's come to me about that, so it doesn't always match up perfectly. And then I can map the decisions that were made. So obviously you still get that interest in cancer, cardiovascular. This is just to say if it at least went to the first shortlisting and if it was selected. But that, you do get interest in other areas. So you get a few in hepatic, which was recently in strategic case, and respiratory and such. And obviously looking at cancer, the majority of technologies are to do with prostate, breast cancer, lung cancer and bowel cancer, but it's just to give you an idea of a flavour, because obviously cancer is such a wide topic. So we can then look at the sources of the technologies. So firstly, I said there was desk-based searches, and obviously they produce the highest number of hits because there's a lot more going on, but around, I'd say less than 20% actually hit that shortlisting. And then we have the network side of things, so this is everything that's referred to me, and I'd say around 50% get to shortlisting. But as you can see, there's approved in both sides. So I still say, not limiting ourselves to one side or another is the better model for us, because then we can we can try and punch above our weight on what we can see. So just looking again at all the different technologies that we've seen, we can now focus it down into just the ones that made it to shortlisting. And basically you see this quite wide range of disease and condition areas. The reason for this is because there's no PICO for this. It's basically, has it been published or sent to me in the last 4 months? So that's why it's such a wide range of topics. But we are still quite inclusive on a lot of different topics. And so there's some different analysis we can do on top of that. So first of all, we can look at the type of medtech, being I'm going to have to explain it to you because you can't see it, but this colour is the medical devices, and then we've got the digital health technologies and the in vitro diagnostics. And a couple of points, obviously about 2/3 of the technologies can be loosely labelled as medical devices, but even at this high level of medtech classification, it's still a bit of a mess, because a lot of digital health technologies that have AI components tend to be registered as a medical device, so that will then bloat the number of medical devices. But despite there being a lot of medical devices, if you remember at the start, we had the pharmacogenetic programs and the digital dermatology, which are actually examples of, in vitro diagnostics and digital health technologies. So it doesn't mean there's so many medical devices yet we have to choose those. And then, I guess, very topical use of AI. Just of those 100 or so technologies that were shortlisted, around 15% were either, explicitly use AI or use an algorithm. And this is largely consistent with the total number of technologies, but this is just quite a quick analysis, so just take this as illustrative. For the last analysis, I'll refer to the Medical Technology Innovation Classification Framework, which I believe was mentioned yesterday. And basically, if it's defined as an innovation, there's three sort of options. If it doesn't exist within the private or public, it is known as disruptive. If it does exist within the private but not the public, it's transformative. Or if it does exist in both, it's incremental. So I tried to map these, but please use these as my own interpretation. But you essentially get majority, again, about 2/3 of technologies are transformative in nature. But this is going to be a high number because, like a lot of technologies, so even taking recently the enhanced liver fibrosis test, that's routine adoption in England, but it's not even used in Scotland, so that's transformative to us, but not to England. So there are a lot of transformative technologies, but you do see a couple of disruptive, but because disruptive is, because of the disease areas we're looking at, they're quite large scale or big problems we're trying to address, you wouldn't really expect to see disruptive technologies in the sources that we find. If there's a big disruptive technology for cancer, you'd expect to see it on the news before you'd see it in a HTA conclusion for us. And then the only other point I wanted to make is that in these incremental technologies, they can still be very important. So recently, the ECG patch monitors, which is basically a different version of it with a battery that lasts for longer, is an incremental change, but still an important one, and that is, in value case, I believe, at the moment. So obviously just some of the references. I didn't realise I should have done acknowledgements, but acknowledgements to all the partners, and I'll leave you with an image of me conducting my daily business. I'd also like to run away, but...
Run away quick enough, so we've got time for 1 or 2 questions. Joshua.
Thank you. That was really interesting, and it was really fascinating to see all the different types of technologies. I couldn't quite see on your last slide where it... I've also forgotten my glasses, so that doesn't help either. But it said technologies of interest, and I wonder if you could say a little bit more about what that slide was actually trying to say, or what you saw as perhaps some of the gaps that need to be filled.
So obviously, I mean, the first big gap, like if you want to match with the burdens of disease in Scotland, substance abuse is a big issue in Scotland, and there's no technologies that address that. And on top of that, I mean, it's because we can only assess a couple of technologies at each stage of the pathway. So obviously there's 4 in there, but a lot of big disease, it's quite difficult because a lot of big disease problems, even prostate cancer, you saw 23% of the cancer technologies are to do with prostate, but we've not actually got any of them in. So I guess there are so many things that it could do, but it's so hard to choose when you have to be so pragmatic. So, I mean, I guess that's why we have our... sorry, I saw a hand, so I didn't know if you want me to stop. But
you can finish, it's fine.
I guess that's why we have our governance body and the shortlisting to then help discuss that, because it can't just be me doing this, because it's already quite hard as it is. I don't really know if I'm waffling anymore, so it's just a very hard topic. Where do you address first? Where do you go first? I guess showing this probably to our governance body and the work we're doing probably would be a good start to just say, these are what we get in technologies. Do you think this matches? What is this the priorities you want to meet? Because obviously the policy documents are very vague as well. So
I think we'll call a halt there, but thank you so much. If you could join me in congratulating Joshua, thank you. So just before we go to our tea break, just a very quick little bit of logistics. So we now have a break for either 15 minutes or half an hour, depending on what you're going to next. So if you want to attend the oral presentations, they start again at 10:45 back in here. So if you are coming back in here, please could you be as quick as possible, especially if you're presenting either the oral or the lightning talk. So if you could just come back in here as quickly as possible for the briefing. If you want to take part in the workshop, that starts at 11 o'clock, so you've got a slightly longer break. That takes place in the aptly named workshop just behind the registration desk where you came in. So if you could join me one more time in congratulating our speakers for some excellent talks. Welcome back, everyone. Thank you very much for coming back promptly after tea break. Much appreciated. I think we've got 1 or 2 people just coming in now, so if you wouldn't mind taking your seats as quickly as possible, we will make a start, because we've got quite a lot to get through in this session. Great, so I think most people are settled in now. So we now have some oral presentations followed by the lightning talks. And the overall theme is the second part of the Exploring Cutting-Edge Methodologies in Horizon Scanning, Foresight and Futures. And it's my very great pleasure to welcome to the stage Wytse.
Yes, thank you, Pauline. I would like to thank the organizers for the opportunity to present our work. So my name is Wytse Bruinsma. I work for the Dutch National Healthcare Institute, where I'm a senior advisor and project leader on several horizon scanning projects. And what I want to talk to you today about is our international collaboration on horizon scanning through the International Horizon Scanning Initiative. And my talk will basically consist of 2 parts. First part, I will focus on what we already have, which is a highly sophisticated horizon scanning system for pharmaceuticals. And then I'll move into the second part of my talk, where I will discuss our plans to develop a horizon scanning system for medical devices. Well, so as you all know, anticipating future when it comes to healthcare is very important. I don't need to explain it to this group, of course. The future is always changing, and we need to be anticipating, because the future is never what you thought it would be. So that's why we wanted to collaborate on an international level also with several countries who are all facing the same issues. So that's why we funded the International Horizon Scanning Initiative, or ICE as we call it, which is an organization. You see here in purple all the countries that are the member states of ICE. It's all funded and governed by the member states. There's no influence from the industry, so no funding or any other type of influence. It's mainly based on collaboration, so data sharing, information sharing, and working together. And it's important also to highlight that everything that we do, we're working with external parties also that develop and maintain our database, but everything is owned by ICE, so the data, the database, the infrastructure, and all the AI tools that we are using. And of course, we are very open to collaboration with other parties aside from the member states here. So all the member states of ICE, they joined because we're all facing similar challenges and having similar needs. So ICE is there to support these governments in creating a resilient healthcare system. We hope to provide the best-in-class horizon scanning system to do so. And using this horizon scanning system, we want to generate actionable intelligence for pharmaceutical policy and planning, so that in the end, we can inform decisions to all the member states regarding to their needs in price negotiations, HTA planning, etc. So to do that, we have developed a very sophisticated database for pharmaceuticals. Here's a screenshot of the website where you can access the database. Well, I must admit that it is not publicly available. Although if you are interested, I'll be more than happy to show a demonstration in one of the breaks to see what kind of information is in there. But what you can do, it's a very easy interface. Look up your favorite pharmaceutical, and you see all the records. So there's a record for every drug indication combination. Look it up, and it has all kinds of information regarding to that drug. So in the database, it's mainly factual information. But what the horizon scanning system also provides are high impact reports. So that is more of a deep dive in the more high impact drugs, where there will be much more analysis and the effects on the healthcare system, and involvement of key opinion leaders in what it will mean for healthcare. So that on one hand we have the database, and on the other hand we also have the high impact reports. And we do this in collaboration with ICARE, which is also a non-for-profit organization that develops and maintains the database. Well, this slide is basically to just show off our highly sophisticated infrastructure, but there is a lot of technology behind constructing the database. So it is a highly automated harvesting and processing machine. So what it does, it looks in all kinds of different information sources, collects all the information, pulls it in one big, what we call a data lake, and then we have all kinds of sophisticated tools to label and curate the data and structure it in fully automated in a database. So this removes a lot of manual curation of the data in the horizon scanning database, and then users can just use the database to look at their favorite drug and all the information that is there. So we use sophisticated AI techniques to do this, and this ends up in a database that contains almost 7,000 records, and each record has the potential for 167 data points. So you need to think about information about clinical trials, indication, future indications, the process of the regulatory process is being tracked, but also price information is in there, patient volumes, or at least rough estimates of that. So it contains a lot of interesting information to be used by the users of the database. So that's our pharmaceutical database. So we've been developing that for some years, and it's actually now online for about a year or so that we're actually using it, and we are very happy with the result, and it really provides high quality data that we use directly in our national processes. But along the way, of course, there were also questions about, can we also do this for medical devices? Of course, it's challenging. It's not exactly the same, but it would be very interesting to see if we can manage to build something similar for medical devices, and mainly because also the budget impact for medical devices is comparable. Of course, it's a vastly different field, but there are also very similar problems that needs to be solved here in terms of how do you pay for it and how do you access all the other different medical devices. Horizon scanning is very resource intense, so that would be very nice if we could automate it to some level, and it's very challenging to do at a country level, so international collaboration is really necessary, and all the members of the IC initiative have agreed that this is something that we should invest in to be able to develop a horizon scanning database for medical devices. So again, this is almost a similar slide as the one I showed you before. The goals are very similar. Again, we want to support governments, provide a very good horizon scanning system that generates actionable intelligence for medical devices. But again, here, the main goal would be to inform decisions in price negotiations, HTA planning, implementation, all the things that we all need to do when it comes to medical devices. So for several years now, we've had a medical device working group within IC to do a lot of research on what is it that we want and how should a horizon scanning system look like to meet our needs. So we've written an extensive report detailing all this research, and you see here the 8 chapters sort of that we've researched during our endeavor. And I want to highlight the top 2. We've done a mapping of existing horizon scanning services to learn from practices that are already being done. And most importantly, we mapped also the national needs of the IC members. So basically what this means is which information do all the members need, at what time, what quality, what do they want to use a potential database for, and what type of information do they need. Part of the results of our report have also been published, mainly the mapping of horizon scanning systems, and also the national needs has been subject of a paper, which are there below. But then we also defined what time horizon we wanted, what outputs, the criteria for inclusions. We planned this all beforehand, or we devised the system in that way. So then we came to a proposal of what we want to do. So this is a very rough overview. Just to give you an idea, the scope would be to include novel medical devices and novel in vitro diagnostics. The products would be a database which contains medical devices which are already at a sort of the product stage. High impact reports, similar to with the pharmaceuticals where we do a sort of an extra analysis. But also include forecasting reports to include technologies which are not developed enough to be already a product, but discuss more of the trends in the earlier phases of medical device development. And similar to the database we already have, we would like to automate the data collection and structuring, and that will result in a database on which base we can decide we can access all the information. So to do all this, we've developed a phase development framework, because of course it's a very challenging task. So we divided it up in 3 parts. First, we are currently conducting a feasibility study. So that basically means we're trying to see if what we want is really feasible. If that will be successful, we will move on to a pilot where a minimal viable product will be tested. And if this all works to satisfaction, and we'll move forward to construct the entire database. So we've now started the feasibility study. So the goal is to provide a decision framework to see whether, what we want and what is out there, if we can actually get all the information that we want and make it into a database which is useful. So the feasibility study, when it's concluded, it will provide an analysis of all the potential information needs, the identification of key data points and concepts. Also analyze input sources, which input sources to use, which are useful, which are not. And in the end, also a description of an algorithmic framework which should be built to collect all this data and structure it in a database. So again, also here, IC is working together with ICARE to develop this. So the feasibility study is currently running and will be finished approximately in June 2026. So then I go to my conclusions. I hope I have convinced you that the IC-ICARE partnership is a proven track record on state-of-the-art horizon scanning, that there's a big need for actionable intelligence. I've shown you we devised a proposal for such a system, and in June 2026 we'll have the results from our feasibility study, and hopefully, if you're willing to have me next year, I maybe could present the results from that feasibility study and our next steps that we are taking. And with that, I would like to thank you for your attention and acknowledge all the people who have worked together in our project. And if you have any questions, there's my email address, or just ask me a question during the break. Thank you for your attention.
We do have a couple of minutes now if anybody has any questions for Wytse.
I see there.
That was a really interesting talk, thank you. So we've done quite a lot of work at the Innovation Observatory looking at software as a medical device. I just wanted to know, would those devices be included in your database? And if so, how are you going to get around some of the challenges in terms of data collection? Often we found developers are quite vague with the details they'll give on how some of these technologies work, on the data that they're trained on. So how do you plan to address that?
Right, yeah, so in principle we have very broad inclusion criteria also to see what is it that we can get. So software is included as medical devices in our definitions. We only, I didn't highlight it, but we only work with publicly available data on the pharmaceutical side, as well as for the medical devices. So we're limited to the information that is available. So if a health technology developer decides to share that kind of information, then we can include this. And if they don't, then we can't. But then there will be a note saying that information is unavailable. So that is how that's a very pragmatic approach with how we approach it. So we're not actively approaching health technology developers to provide extra information. In practice, that is something that the member states that use the database do in their national processes. Any other questions?
We've got time for one more quick question if anybody's got one.
Thank you for a really interesting overview. I was just wondering around, and maybe I missed it, so apologies if I did, but the objective of putting this information together and how it will be used, I guess, from a national, like from a government perspective, as opposed to as a way for broader technological developments by different medical device companies, to kind of fill the gaps that maybe this highlights. And how
so this is just to give like an overview of what is being developed, right? So everything, so we don't use this from a demand perspective. I mean, so what we do is we collect all the information to sort of level the playing field. This is all the information that's available. This is what's coming. And then member states, they can use this information for their own, and most of the organizations use this for their own HTA or other assessment methodologies. But you're raising an interesting point. It doesn't answer the question of what technologies would we actually want from Although I must say, if you have the overview, you can maybe also spot the gaps. But indeed, that is a different approach. And in this case, we're just mainly collecting the information of what is. But then maybe in the high impact reports or the forecasting reports, we have room for discussing the questions that you're asking.
Okay, thank you very much.
That's it. Thank you.
Thank you. Thanks very much. Please join me in welcoming to the stage, Claire.
Hello. I'm Claire. I'm a research assistant here at the Innovation Observatory, and I've been very fortunate the past year to be working on some new innovations. It's very exciting. So I'm going to present what we've done so far, and then going to give you encouragement to stick around the conference until later on. Usual. So bioengineering, it encompasses a massive wide range of topics, research and technology. It combines fields in engineering, it combines fields of biotechnology, and it presents challenges, especially when it comes to horizon scanning. Additionally to this project of bioengineering, as an information specialist as well, we were given a very broad research question. We were given very limited time to deliver some of the insights, and our stakeholders didn't pre-specify what was needed. They wanted to know rather what they should be concerning themselves with, which, as I say, as an information specialist, that's like terrifying. But damn, it's a good challenge, you know? It's a really good challenge. They want to know what's potentially game-changing in this space, and let's get our teeth in and deliver that. I'm just going to highlight, this is the HIPD framework, and there's a lovely little QR code I encourage you to take a scan of. So how are we going to do this, though? That's a very big question that was on my mind and puzzled me and kept me up at night. We did this, so I'm just going to give a shout out to Katie Twentyman for helping us produce this lovely visual. So basically, horizon scanning looks for weak signals. It looks for those subtle indicators that become significant in the future, and it follows, the method follows a flow of actions. It starts with identification, which is the emerging of issues, trends, and innovations. It's followed by filtration, which removes irrelevant and low-impact signals. And then it goes on to prioritization of signals, and that's based on the potential impact and the relevance, as well as what the stakeholders need. Please keep in mind, they're wanting us to tell them what's out there, not what they need to know. And I've already said bioengineering encompasses a wide range of topics. I've already said it presents unique challenges. And I've already said I'm an information specialist. So how does this all tie together? Well, what we needed is to better define and narrow the topic. We needed to effectively move away from traditional keyword searches. Scary, very scary. And because of the volume, the complexity, and the diversity of bioengineering, we needed to develop something new. So we developed a multi-step approach that overlays traditional horizon scanning processes with our innovative approach, which uses network bibliographical visualization analysis. And that's what this visualization depicts. Let's go into a bit more detail though, shall we? So we opted to undertake a bibliometric analysis to say what was out there. So to do that, we wanted to look at the co-occurrence of a large set of data from bibliographical records that we retrieved using Embase. The search strategy was developed to maximise sensitivity and intelligence gained from the texts. So we used free text unspecified strategy. If you want to know about the strategy, I can point to it later on. We looked at three concepts: bioengineering, genetically engineered, and synthetic biology. And these were chosen based on recent literature that we were able to find. The only limiting factor that we agreed on with the stakeholders was the publication limit. We wanted recent, so we looked from 2020 to 2024 when the search was conducted. We used VOSViewer, which I think we had a little allusion to yesterday. This is going to go into a little bit more detail, hopefully, on what we can do with it. What VOSViewer does, it looks at a raw list of keywords, and we did was extract those as a project team and manually clean them. This resulted in several columns of data. So we looked at those specifying that related to the specific areas of interest. The 3 areas of interest we wanted to look at were tissues and medical devices, therapeutics and delivery systems, and genetically engineered organisms. As well as looking at a list of excluded terms, we needed to get rid of the stuff that wasn't relevant, and we wanted to standardise some of the keywords as well. Any keyword relating to any specified new tech and unmet needs were also categorised. They were kept to one side just in case. So using these clean lists, we created a thesaurus, which means we could upload that into VosViewer and then actually generate something useful, something that we could use. So the network map was created using nodes and edges. And if you're not familiar with VosViewer or these type of maps, a node represents entities in the network. So, for example, that could be an author, it could be institutes, it could be the keywords. Clusters are a group of nodes which are closely related, and that's based on the strength of the connections. And clustering allows identification of patterns and thematic groupings. Edges represent the link between them. So, for example, any collaboration between authors or shared keywords, and that was what we were interested in. Data outputs from these network maps were used to create a graph with a bell curve, which informed our focused search. And I will actively encourage you to go to Dr. Pauline Addis's presentation at 3:50, when she will go into a lot more detail about the bell curve. So, what does it look like? This lovely piece of art was the effect pre-process. This is the VosViewer map using M-based search strategy before any of the cleaning process took place. It encompasses all the items that was located by VosViewer, and it just shows the breadth and the complexity of bioengineering. And you can't see anything. So what our process did was this. This is specifically looking at tissues and medical devices. We do have several. Isn't it pretty? So, just to give you some data, the M-based search found 4,439 results. VosViewer generated 4,266 items from it. Wow. From this, the project team were able to create bespoke thesaurus lists for the genetically engineered organisms containing 119 keywords, for tissues and medical devices 123, and for medical devices, therapeutics and drug delivery, it was 259. 2,201 keywords were excluded or grouped under single umbrella terms. So we excluded things like activated sludge, and when I tell you activated sludge ruled my life for several months. Plastic, and I finally got rid of my yeast problem. Other terms were grouped together. So, for example, we had liver, liver cell, liver organoid, and liver tissue. They were, unsurprisingly, grouped under liver. Each of these different colours as well, they represent the cluster of information. So you'll have seen from the presentation yesterday how we highlighted the different colours. It, again, shows it here. So this was produced specifically for tissues and medical devices, which generated 12 clusters. This now meant that analysis could turn to each of the clusters individually. We could delve a little deeper into it. And all the keywords within each cluster were ranked based on occurrences. So this means the frequency with which each appears in the body of literature. From this, it created the bell-shaped curve. This is just an example. The overall most frequently occurring and newest keywords were analysed, with the rationale that the most common keywords are those most frequently mentioned in the literature, representing a strong signal, and therefore it's going to be of interest to us and our stakeholders. So this means we can look at different databases, clinical trials, other bibliographical sources such as PubMed, looking exclusively for these technologies. So, implications and recommendations from what we've spent a year of my life doing. It complements traditional expert-driven methods. I didn't lose being an information specialist using pretty pictures. I think I made it better. It also helps reduce bias a little bit as well. Like, that's a very important thing as an information specialist, is to reduce bias in our searches and in the information that we look for. As researchers, we don't want to introduce that. It's transparent, it's reproducible, it's useful for identifying emerging technologies by analysing the patterns in scientific literature. The successful application of using VOS Viewer demonstrates that bibliometric tools can be incorporated into horizon scanning technology methodologies, and it can enhance the detection of emerging trends. As well as supporting policymakers and researchers in identifying gaps in innovation, findings can inform funding priorities and early stage research investments. But also the scope to enhance it. Future work could use different data sources, such as funding pattern sites, using other bibliographic searches as well to support MBase, pattern data as well. So basically, if you can search it, we could probably add it in and we could try it out. And to maintain relevance and accuracy, though, the user-generated thesauruses that help create these maps, they need to be periodically reviewed and checked and maintained. Because of the challenging area that we looked at, and with any research area, you do need to make sure you keep that relevance. The report is published as of Tuesday. I am so happy. Please, QR code. I'm just going to pause here for a second because I probably have been speaking very quickly as well. But yes, we published the report to the Innovation Observatory website on Tuesday officially. It is there to look at in a lot more detail than I've been able to go through. This is a complimentary presentation. However, I would like to draw your attention to a couple of other presentations that are part of the game-changing project. At 2:15, Dr. Megan Fairweather is going to be talking about the wearable devices, which was another part of the game-changing. But if you'd like to delve a little bit more deeper into the results of what this methodology was actually able to produce, Dr. Pauline Addis is presenting at 10:04. I actively encourage you to go to that one. Both of them, actually. Hang around. This is the research team, without whom this would not be possible. So a big thank you to them and for the support that they've in developing it. And because I love a QR code, that's a report still. But yes, if there's any questions, I'm happy to take them. If not, I'll sit down. Thank you.
We have 2 minutes and 51 seconds for questions.
I didn't time that well.
That was an amazing presentation. Well
Thanks.
done. I'm so inspired. On your the manual part of clustering the terms and the thesaurus part of it, did you have to consult a bioengineering expert, and how did that work in practice?
We did not consult a bioengineering expert. I think going forward, that depending on the complexity and the nature of the project that you're looking at, it would definitely be something that engaging in that expertise would be helpful. The majority of the thesaurus building, that the filtration at that point, was done by Pauline, Rhiannon and Megan, who did a spectacular job. I was mostly moral support in the room at that stage, and was the independent adjudicator when there was some contention. But it is definitely something that we think going forward will be useful. And this is a reproducible methodology. So if you do have an expert in that particular field, you've already got the person in the room that you need to address it and apply this to. The report should detail it enough that you'd be able to reproduce what we've done.
Thanks. Equally impressed with the presentation. A similar point on the thesaurus. Just now that you've been through the manual side of it all, is there opportunities for automation?
Oh, heck yes. You don't even need to finish that question. Yes, it is one of the key learnings from the project that automation would be incredibly useful, and it's something that we would like to look at further into if given the opportunity and the chance to develop and test it out. Wearables, correct me if I'm wrong, I wasn't involved in that, did use some automated tools in some of the screening process. Yes, I'm getting a nod. In the screening process, which we didn't. So we already know that there are some systems in place that we could utilise, but 100% it was the most laborious part of the entire process. We would actively encourage and want to look into that development.
Cool.
Oh, there's one
Go
more.
on, if as long as it's quick, because you've got 16 seconds to ask it.
I'm a fast talker.
Now you've said you've sort of got a reproducible method, you've come up with a really good way. Are you planning to try and like replicate this, but with a different topic, like with different type of innovation or something like that, rather than
I
just
would absolutely love to, but it does depend, and I'm looking at my boss, what work streams come in as to what we can do. It could be that we test it further as a complementary method rather than the single method that goes down. So watch this space, hopefully, in the future. But that doesn't stop you guys and, you know, crediting the report. I'm going to go off the stage now before I get kicked off. Thank you.
Really, really well done. Not that there's shameless self-promotion or anything going on, but I realised I actually told my time to Claire as 3:50, not 3:15, so that is on me. But yes, if anybody does want to come to my talk, and it is really good, I'm on at 3:15, not 10 to 4. So yes, please do come along to that one if you would like to. Are you sabotaging me, Claire? Thanks for that. Yeah, Paulie's talk is tomorrow. It is this afternoon. Super, thank you very much for that. So we have one more speaker in this oral session, and please join me in giving a very warm welcome to the stage to Flavia.
Hello, everybody. I'm here to present our project on innovative approaches in early childhood policy. The background here is that we had in Brazil some challenges in public policies targeting health equity because we have complexity of multidimensional strategies involving multiple stakeholders, and especially in the promotion of long-term human development from early childhood onwards. Thus, we proposed to approach mixed methodology research with the combination of horizon scanning and future foresight to identify optimal policy budget allocations and trying to provide savings for the public sector at local level, that is, at the municipal level. Because we have some laws requiring budget planning in advance, that is the pluriannual planning of budgets for 4 years onwards after the elections. So we try to implement in an interactive manner this budget allocation planning to prevent policy drawbacks, especially when thinking about public policies for early childhood in vulnerable communities. The focus of the project was the application of horizon scanning and future foresight for design and implementation of tools for public policy decision-making in early childhood strategies towards equity promotion in Brazil. And the objectives were the creation of a simulation model for early childhood interventions and adaptation of this model to unmet needs from stakeholders at municipal level. This proposal was implemented in five stages using mixed methods approach to identify these community demands. First of all, we used qualitative techniques, especially mapping stakeholders' unmet needs and using local data to calibrate the models. And second, quantitative analysis to try to identify trends of policies and validate the model looking backwards. The systems approach was used to select the optimal budgeting strategies using an agent-based model that was able to predict interactions among neighborhood districts and show us trends throughout time. We try to gather as much elements that could influence early childhood outcomes as we could at the local level. The computational modeling was based on this 5-stage process that I mentioned before. The first stage was horizon scanning to detect innovative interventions at local level. The second was signaling analysis to identify emerging trends and potential opportunities, for example, expressed through the unmet needs in the discourse of stakeholders. The third step was translation of these insights into computational algorithms using the agent-based model. The fourth step was scenario projection, trying to predict impacts of changes in policy interventions in relation to early childhood outcomes in the future. And the fifth step was to produce an adaptive digital platform that could be used by policymakers to push some evidence-based decision-making policy, especially in budget allocation. We then made a pilot study based on secondary data and a real-life implementation of the study with an iterative process exchanging ideas with policymakers at a local level. And here I present to you first the results of the pilot study. We were able to predict potential impacts of increasing conditional cash transfer program coverage in the city of São Paulo in relation to reduction of occurrence of low birth weight in this, throughout the city. So we were able to identify changes reducing inequalities in the prevalence of low birth weight in São Paulo city. And it was a pilot study just to see if we could implement the model and validate the model using past time trends. That therefore we used secondary data to see what was like the present and try to predict the past using the secondary data. So the model was able to show this, that we were able to validate the model using this past data. And in the real-life study, we identified some specific unmet demands and innovative strategies at the local level in another city, that was Campinas city, which is our partner in the project. And they were, in actuality, interested in trying to see whether or not increasing the coverage of family health teams in the city could help reduce congenital syphilis instead of low birth weight. So we adapted our platform to try to show whether or not we could do better budget allocation to prevent this occurrence of congenital syphilis in the city. And an increasing coverage of family health teams could be able to reduce a lot the occurrence of congenital syphilis among children in Campinas city. So therefore, we could see a practical application combining horizon scanning and future foresight, identifying pioneering early childhood interventions that were applicable in the reality of this city, and projecting these impacts from alternative policy strategies to see whether or not this could impact early childhood outcomes. And in addition to that, we were able to engage effectively stakeholders in this evidence-based planning of budget of the city, because we were able to recognize the specific unmet demands at municipal level and gather the support of these policymakers to design this flexible computational tool for their use on ongoing basis. And then we are now implementing this evidence-based policy planning in Campinas City. Hopefully, until next week, we will have the final results of all this implementation, including feedback from the stakeholders. And I would like to acknowledge my teammates, my research team, and also the funding of the São Paulo Research Foundation and the National Council for Scientific and Technological Development that supported this research. Thank you so much. If you have any questions,
Thank you. Another great presentation. I'm assuming from the maps, but please clarify, was there a spatial or geographical dimension to the modelling?
Yeah.
Was there, I'm cheating, I want two questions. So spatial dimension, and also was the budgetary dimension looking at primarily the health dimension, or were you also able to look at other municipal budgets like housing or employment or social welfare or anything like that? Thank you.
Sorry for interrupting you in the first question. Yes, it's, the geographical dimension is very important because we were really interested in seeing inequalities that were occurring at the local level and then tackling these inequalities through the agent-based model to reduce inequalities, not only to reduce the occurrence of negative outcomes in early childhood, but also to address inequalities, to try to make the most vulnerable communities being able to reach a higher level of early childhood outcomes. So yes, we used that. And I presented mostly data on the health, budgeting and health policy dimensions, which are my specialty, but we were able to access also education and social assistance indicators, both in budgeting and in health and other outcomes for early childhood. But as this was a synthesis of the work, we concentrated mostly on health issues. Any other questions? Okay.
Thank you, Flavia. That was a fascinating presentation, and what an incredible piece of work. I just wonder, well, a few things. I mean, the complexity of what you were trying to do and the complex nature of the different sources of data. I just wondered, how did you draw on all that data? Did you use existing evidence synthesis to inform your modelling? And were there any gaps? And were you able to use evidence? Did you find that it was contextually relevant, or did you then have to adapt it? And how did you do that? Sort of technical question. And then I'd just love to know how policymakers responded to your findings. Thank you.
So the work started several years ago with a postdoctoral supervision of one of the research team members, and he was able to gather evidence on the best ways to approach this modeling, agent-based modeling system. And we based the construction of the model on some validated and previously used methodologies. So we did not address a theoretical gap in the literature in terms of methods and techniques, but we addressed a gap in the public policy field, that is the use of those methods and those techniques to public policy decision making. Because these methods are quite consolidated in the area of computational simulations and other techniques like that. But, and for example, there's a whole field on complex systems modeling that we were able to explore during this postdoctoral stage. But afterwards, we were able to see that there was a gap in public policy implementation. and that the laws established in Brazil for budget planning required more sophisticated tools than the policymakers had at the time. So then we try to take some techniques from the computational background and put in public policy decision making. The policymakers were really open to the use of the computational tool. Of course, there are some resistance, but we were able to capture the interest of one guy that was really influential in Campinas, and he therefore signed the agreement really quickly, and he said, we are going to push this through the administration because I think we should modernize public policy decision-making in Brazil, and we don't have techniques, tools, and capabilities installed in most municipalities in Brazil to do that. So we look forward to contribute, to collaborate, to try to make this tool adaptable, easy to use by policymakers. So he embraced, and as he embraced this opportunity, we were able to show to other municipalities and try to disseminate the idea throughout Brazil through forums of policy stakeholders, public policy decision makers, and then we are getting more interest as the project is spreading out through communication with stakeholders. But it was key to have one guy that believed in the idea from the first moment.
Great, I think we will wrap that
Thank
up
you
there.
so
Thank
much.
you very much, Flavia. So that concludes the oral presentation section of this particular session. We're now going to be moving on to the lightning talks. And to keep things snappy, there's not going to be Q&A at the end of each talk. And also, if I could ask the next presenter to make their way down towards the stage as soon as the previous person's wrapping up, that would be great. So, our first one of the lightning talks, please welcome to the stage, Phil.
Morning, everyone. So I'm going to make this really rapid, so apologies if I speak really quickly. But I'm slightly hindered by having the longest job title in the world, which is Head of Nursing Therapies and Quality for Mental Health, Learning Disabilities, Children, Young People and Families for Dorset Healthcare University Foundation Trust. I think that's my time. No, but also I have an internship with Arc Wessex, and what I wanted to do today is share some of the methodology that I used in my PhD to really try and promote inclusive conversations around future technology. So I looked at exploring the impact of technology on future citizenship for people with mental health challenges. Citizenship in this sense is really thinking about how people are included and excluded in their communities, in services, in society more broadly, or even in sort of more intimate relationships. So what I did was I was very, very fortunate to have 3 peer researchers that I worked with, Bex, George and Ian, and we worked together on interviews with people from a peer-led mental health organisation, so everyone having lived experience that works in that organisation, and a digital tech company. And we asked questions about what do you think is going to happen around citizenship, what do you think the drivers are around technology, how do you think that's going to play out. We then had a co-production workshop, brought everyone together to try and explore what we thought was going to happen. And then we ended up with a load of data, and all our heads exploded, and we were like, how on earth do you actually communicate this complex information to people in a way that's helpful and useful? And this is really where some of the kind of co-production came in with the peer researchers, as we thought, let's make a film. And we ended up making a sort of future weather forecast, news forecast set in 2042, which is, I've got some clips to show you. I think that's not going to start yet, that's good. So I don't want to get sued because I've spliced a film together, so I just thought I'd explain a bit. The first interview, so there's myself and Bex in it. In this, I'm just standing still, but I actually do talk in most of the film. But Bex plays 2 different characters, but it might not be that clear to start with. The first one is someone who's using services in 2042, and it's a bit imagined around what those services are. And then the second conversation is with Bex as an activist. And we try and pull out the ethical issues. So I'm just going to show some clips there. And in the first one, Bex refers to Roy, who is a robot support dog.
Our forecast today comes from the perspective of people who have personal experience of mental health challenges and or work in the technology industry.
Receive support from the mental health team. I have a virtual key worker who I can contact 24/7 and a human one who is available to meet in virtual reality during office hours. They are both able to monitor my mental state through an app that has been installed in Roy and also in my DigiWatch that keeps an eye on the chemicals in my body and blood pressure, etc. So they can remotely amend my medication as and when required. They have also helped me to get whole lenses, which are glasses that can filter out overstimulating environments and can help with my flashbacks. The glasses also allow me to do an augmented reality aerial yoga class. You know, I could be sectioned and held on a home lockdown and tagging order, all done remotely without my involvement. Routine, structure and automation can be very helpful, but not at the expense of conscious thought. I argue we are sailing close to the wind, limiting choice, controlling choice, having no social connections in person. Before we know it, we will have more in common with machines. Are we going to let risk management drive away what makes us unique?
So then we played that back to the peer-led organisation, and these were the themes, and I think we've heard these themes throughout actually the conference, which is around who holds the power, who benefits from these technologies, who's sitting behind it, whose interests do they serve. There was a real key theme around what it means to be human, and how, I'm doing better than I thought. I've got my yellow card, I'm doing better than I thought, that's good. What it means to be human in a digital world and not losing that sense of connection with others, but also how technology can potentially enhance that. There was real concern about division and that being in multiple directions, poverty being one, but also across all sorts of health inequalities as well. And then the fundamental thing was that people wanted to be involved. People wanted to be involved in decisions about technology that impacted on their lives, and that the role of having a voice, being heard, being listened to was absolutely core. And really, I just wanted to sort of illustrate that hopefully creative methods can support this, but co-production, and we've talked about tokenism, is so tricky, and it's so important that we're engaging with the dynamics of power and inequalities, and we share our learning about the difficulties that we have around co-production as well as the successes. And then if you want to read the actual findings, they're there. Thank you very much.
Yes. What if one of the most iconic medical devices, the fingertip oxygen monitor, had never made it into the hospitals? This device is now a form of standard care, but once it was a breakthrough innovation. We could measure oxygen saturation non-invasively with just a simple clip on the finger. And it transformed patient safety, especially during surgeries or in intensive care. But imagine if the device would have been delayed because it did not meet all the reimbursement requirements. How many lives would have been affected by that? Today we face similar challenges with new technologies such as wearables or image-guided therapies or the 3D printed prostheses. And some assume to be ready for clinical use, but if without the early alignment with the reimbursement requirements, they risk on being left behind. And today, my name is Rose Kolthoff, and I'm educated as a technical physician, and that role is designed to bridge the gap between clinicians and technologists. So I work closely with both engineers and also with clinicians to assure that the right innovations actually get to the patients. But now I work at the Dutch National Healthcare Institute as an advisor on medical technology, where I work on building a new kind of bridge from the policymakers to the engineers and the clinicians as well, to assure that promising new technologies do not get stuck in the system. In the Netherlands, we have 4 criteria that makes care actually reimbursed, and that's effectiveness, cost effectiveness, necessity and also the feasibility. And but many new technologies that are ready for clinical use do not yet meet these 4 criteria. And that doesn't mean they are ineffective, but it's just that the evidence is not complete or not aligned with the policy requirements around reimbursement. And this leads to delays in adoption, and that's causing patients waiting, developers struggle, and also hospitals missing out on promising technologies that could improve care. And that is why we have developed a targeted horizon scanning system for medical technology, a structured and risk-based approach to identify promising technologies that actually could benefit the Dutch healthcare system, but currently fall short on reimbursement criteria. And our system follows a stepwise method. We identify and prioritize the trends in medical technology developments. We conduct an in-depth analysis and then also start conversations with all the stakeholders involved. And in the end, we set the agenda for reimbursement-related questions. We focus on trends with a high potential impact on the Dutch healthcare system, such as the wearables and the image-guided therapies. We do this by desk research, stakeholder input, but also reviews from the experts out of the field. And this helps us on guiding our selection of the devices. And we aim to support developers early, helping them align with the reimbursement criteria during the development instead of at the end. But we want to work towards a system that not only identifies innovation, but also anticipates it. And that's why we are enhancing our horizon scanning approach with an AI-based methodology. This can automatically collect and analyze emerging innovations across Europe, as you can see on the map. And this helps us on spotting emerging technologies earlier, but also more accurately. And with this, we move from reactive to proactive, guiding innovation before it actually gets stuck, and ensuring that the bridges between the policymakers, the clinicians, and the engineers are actually made from the very beginning. So thank you.
I'm back. Okay, I'm going to present quickly another research project that I'm currently undertaking. You know, I'm an information specialist, so the methodology in searching and different ways to search is very, very key to my interests. Usual. So the objective of what this project work is, and I'm going to emphasise very heavily it's a work in progress, is a case study to explore the utility of citation searching in mapping the path of research method as it transitions from novel to adopted and then embedded into everyday practice, and it's using citation analysis. The study aims to answer the following questions. What are the key publications that have contributed to the development and the adoption of target trial emulation, or TTE, which is our research method of focus? Are there identifiable development points in the adoption pathway, and what insights can be gained from the case study of using TTE that may be generalisable to the adoption of other emerging research methods? So what is citation analysis, if you didn't know? Usually it is a complementary method to traditional searching. It starts with a known paper or papers, otherwise referred to as seed papers. Backward citation searching focuses on uncovering previous or foundational works that have helped to inform the known articles. And forward citation searching uncovers newer articles from the known source. In our research, we're reviewing the citations and looking for relevant papers that talk about TTE, or that feed into the development of target trial emulation. And it's important to identify papers that are frequently cited together, so co-citation coupling, or things that share similar research and methodologies are of particular importance to us. What's target trial emulation, though, I hear you ask? It's a promising emerging research method that has been selected because it's still quite fresh. It's an approach used to analyse observational data in a way that mimics randomised control trials, RCTs as everybody comes to know them. And the adoption of TTE appears to have increased following the publication of a framework in 2016 by Hanan and Robbins, though Robbins has been actually exploring in this space since at least the 1970s. On the screen, I've outlined a framework that's been described in the 2016 paper. We've been using the TARSIS, the Terminology Application Reporting and Citation Searching Statement. Backward citation searching will be used to identify works that have helped inform the development of TTE. These papers have helped form the Hanan Robbins paper. So, 10 papers which specifically look at target trial emulation or trial emulation have been selected. So this is our starting point. Using software citation chaser and Web of Science references, we've taken the references from the seed papers, downloaded, and we've screened in Covidence. The full text stage, we screen those as well, and any that are included at that point then inform the next stage of the process. So it's very iterative. So what we did was, from the original seed papers in what would classify as Block 1, we had 283 references to which we could screen. Of these, 88 were included title abstract and 76 were included full text. Those 76 informed Block 2. Block 2 had 1,601 references. Myself and my colleague Nicole, we screened all of those. And in the end, after full text, we had 110. And it's moved on to 2,569 references, which, full credit to Nicole, she was an absolute screening demon and managed to get through the majority of them because she knew I was preparing for this conference. So what this means is we've actually screened Block 3 and we're on a full text and we're taking 35 texts forward at this stage, but that's not the end. We do also want to look at the forward citations that are from the Hanans and Rubens. So what we're hoping to do is be able to see the key points within the development of citation, look to see if it's applied methodologies that are actually informing it, and what are the citations and the papers that are being used, help us identify the key development points in a research method, and that can be taken forward in being able to provide useful advice to applied researchers, keep key funders abreast on the situation, and basically just see if we can intervene at any point and potentially even speed things up. That's the protocol QR code, and I'm off the stage. Thank you.
Magic of technology, we now have a video which is being loaded up as we speak.
Good afternoon, everyone. Good afternoon, everyone. I'm Aryan Chaudhary from Biotechosphere Research, a unit of New Nexus Healthcare Private Limited, India. It's a pleasure to join the Future Foresight and Horizon Scanning community here at Newcastle. Today, I want to explore a simple but a powerful question. As AI transforms health and care, how do we guide that disruption towards the inclusive and ethical features? AI is advancing at extraordinarily fast, but disruption isn't it neutral. It can empower but can also exclude. Over the next few minutes, I will take you through two key themes. Number one, how AI is evolving into a system-level disruptor, reshaping the entire care ecosystem, and how we ensure this disruption is inclusive equitable, and ethical from the outset. Let us start. AI is no longer just automating isolated tasks. It's now driving holistic ecosystem-wide transformation. Starting with the system-wide transformation, we are seeing entire workflow redesign, care coordination improving, delivery model shifting from linear to connected system, real-time insight and predictive power. AI's ability to process vast multimedia model data in the real time is turning point. It moves us from reactive care to predictive, preventive, and personalized strategy. This means early intervention, better forecasting, and more informed decision making. Third, data-enabled responsiveness. With the continuous data from wearable EHRs and the population health tool, system can now adapt dynamically, almost like a living organism. But disruption also brings risk bias, digital inequality, workforce readiness challenges. If we don't address these, AI will widen the gap it means to close. This brings us to the heart of the talk, how we shape the disruption responsibly. Let's look into it. As AI reshapes healthcare, we must ask who benefits, who risks being excluded, and what do we do about it today? Number one, confront bias and gaps. AI mirrors the data it learns from. A lack of diversity in data leads to inequitable outcomes. So we must actively identify and mitigate bias and close the digital infrastructure gaps that leave many behind. Second, embed core principles. Trust requires transparency, equity requires intention, accountability requires governance. These principles must be integrated from design to deployment, not patched on later. Number three, practice inclusive foresight. This is where future thinking becomes essential. When we bring communities, clinicians, policymakers, and technologists together, we anticipate united consequences and shape more resilient AI futures. Ultimately, AI-driven disruption is not just technological, it's a sociological choice. With inclusive foresight and ethical foundations, AI can strengthen system, expand access, and create more human-centric models of care. Thank you and for giving the opportunity to present this. Have a great day.
So I will talk now for the next few minutes about this. I'm a PhD student, working with a lot of lovely people here, being supervised by amazing researchers, and I joined this amazing environment from 5 years of working, producing, trying to turn systematic reviews and maps into interactive websites as part of my job, and also trying to ensure it's done in an equitable way. I quit my job and I came here because I thought there's so much more to be done, actually, than I was doing. What I was doing, I was producing systematic reviews, mapping reviews, maps. I was trained to follow Prisma protocols that are well established, creating very long documents with a lot of stakeholders. Then, you all know probably how it works: screening, searching, screening, extracting, synthesizing, following these guidelines. So I was asked to answer important questions by decision makers, by policy makers, by practitioners, by evidence intermediaries. So that felt really meaningful. But at the same time, I was asked to do some more, as I mentioned, do some interactive stuff, create not just
reports in a static form, but actually websites use software that, where things start happening, where the user actually needs to not just read a full block of text, but actually has the opportunity to dig deeper into some of the findings. Some of the things also, it makes it dynamic. You no longer need to, wait ages for a report to be updated, but it just takes a few clicks for new results to appear. You can filter it, download it as you want it. So that was really cool. But at the same time, I felt, to be frank, quite ill-prepared for this job because I was not trained really in software development. I was not trained to kind of, I was sharing a link with people, with decision makers, and then I found out that either they could not open it, or either it was too slow, they didn't like something, they asked me to change something. I didn't actually know whether I can change it or not. Some of them asked me to visualize effectiveness results in colors using vote counting approach, which is kind of a no-go. And I really started to actually facing these difficult situations. And at some point, it got even more difficult because we found this, me and my colleagues, we found that there's actually a chatbot which uses the data from our repository. We created this elaborate repository and created maps based on that. But we found that actually other people started using our data to come up with even more interactive stuff and start, using it. Like in this case, this is a chatbot by the World Bank Group, one of our partners. And I know you probably came across similar other ones that are starting to emerge, where they're presenting you findings. And the interesting thing is not just a ChatGPT, but it actually presents you findings based on an actual, quantitative meta-analysis based on 7,000 randomized trials extracted, pre-extracted, and it uses basically a randomized random effects meta-analysis, something that you can really trust. You can see some charts with it, links to studies, and I think that's something that Will alluded to. That's actually there's going to be a lot of innovation in this space. We're going to see a lot of shift from these static PDFs to these dynamic outputs. So that's why I really wanted to be part of the game, and I came to Newcastle to try to shape that and actually come up with some rules to make sure it's responsible and equitable, because that's a big risk, as we all know. So yeah, the opportunities are there. We know there are already intuitive online tools that inform decisions. I will take a little bit of water. And but the reporting guidance is only for static documents, an obvious gap. We also know from Will that there's a lot of interesting stuff happening, a lot of really passionate people from around the world getting together to create this evidence synthesis infrastructure collaborative. So I really want to be part of that group. I love those guys. So that's my small contribution to what they're doing. But there's a lot of barriers, as Will already mentioned, that we need to face. Compounding discrimination based on a lot of dimensions that have historically excluded and are still excluding too many people. That's not easy. Oh, sorry. Yeah. So sorry. And so the question is, how do we make it more equitable? I do want to do 5 quick things very quickly. Review what exists, engage equitably through monitoring of key stakeholder groups, minimum threshold for representation, testing some cost-efficient methods that researchers like me could use to implement it and make sure that their outputs meet the needs of users, evaluate it consistently, and then gather consensus from experts to make sure it's rolled out. Thank you very much. Sorry for being late.
Hi. So good morning, everyone.
it's not morning anymore. I'm very grateful for this invite to present, to have the opportunity to present our work, which was a part of the MLTC, so multiple long-term conditions, cross-NHR collaboration that we kind of put together the application for this project and also undertook the work on how AI-enabled diagnostic tools for mental health may be widening inequalities specifically for people with MLTC, so multiple long-term conditions. So this work is a collaboration of a national team, but the driving force behind is our newly appointed early career researcher Amanyat, supervised by Salwa, myself, and Hajira from Southampton. So the questions that we pose ourselves is, do these tools or models incorporate the social demographic and other variables needed to ensure equitable performance across population? And our starting point was a population-based cohort study using routinely collected primary care data, or CPRD, data set focusing on people with multiple long-term conditions. So that was briefly a 7 million of patients over 34 years. Alongside cleaning that data, we also were doing a scoping review through the 5 databases to identify models used for diagnosing mental health complications. So by identifying and shortlisting 5 predictive models, we then extracted all the variables that they use for their algorithms and mapped them both against the well-established equity framework, so the Progress Plus and Core 2 plus 5, as well as map them against this MLTC data set that we got from the CPRD. So it's like a cohort from the CPRD data. And this helped us to address the question, to what extent do these models account for social and structural determinants that drive health inequalities. So this is the process I briefly described, and I should also acknowledge the contribution, the public contribution of 5 members of the public, but also patients with lived experience that helped us both shape and evaluate or kind of sense check each of the work packages within this project. Here we can see that so we simulated how the model performance would change when equity relevant variables are removed, and we've done that to both quantify the potential bias, identify subgroup disparities, and how variables are confounding between themselves, and we use this relative index of inequality to quantify these disparities. And what we found is that even the best performing, so that's the figure that you can see at the bottom, even the best performing model captured only 50% of the so-called equity determinants that we were observing from the frameworks.
Sorry, Anna, you're going to have to give us the take home.
Yeah, so I think a very important point was also that none of the authors that reported those models have included any PPIE, so any patient or public involvement, which definitely is something that should be addressed in the future. Thank you.
Great. Well, thank you very much to everyone. Some absolutely brilliant talks. Thank you so much to all of our speakers, both oral speakers and those that gave the lightning talks as well. So the good news is we now have a lunch break. If everyone could come back in here for a couple of minutes before 1 o'clock so we can kick off the panels bang on 1 o'clock, that would be much appreciated. And please could you join me in giving a very warm thank you to all of our speakers.
All right, hello everyone. We're going to get started in just a couple minutes here. Now, you have drawn the short straw this afternoon, I'm afraid. After some terrific innings by both Pauline and Kate, you now have me as the compere to bring this conference to a close. But it's not about us, it's about our speakers, and we have got an afternoon full of them. We have got talks, we have got panels, we have got workshops, we have got a prize draw, where we will be giving out prizes worth hundreds, hold your gasps, you heard correctly. We will be giving out prizes worth hundreds of Great British pounds, so please do pay attention because it is a democracy. We will be voting for your favourite lightning talk, your favourite poster and your favourite talk. That is some way away though. For now, I would like to introduce our final keynote speaker of this conference. Please give a round of applause for Chris Taylor.
Thank you, James. Good afternoon, everybody. Chris Taylor. I'm the sustainability lead at Philips Electronics, covering UK and Ireland. Been with Philips about 11 years now. Actually created my own job, which is one of the great things of working for Philips. Worked in engineering originally for many years, all across Europe. Been very lucky that way, but always had a very keen interest in sustainability. And for the last 5 or 6 years, I've been working in that field and ultimately created my own job, which was quite unique within the Philips organisation. So I'll hopefully get this without breaking it. Oh, there you go, that's me. Right, just to start, I'm going to try and wake you up a little bit because we've just had his dinner, so I appreciate everybody might be a little bit sleepy. Climate change. Who believes in climate change? This is not, by the way, you don't have to believe in climate change. It's just an interesting talk. That's good. I always like to have a skeptic. Who's got doubts about climate change? No, I'm going to put my hand up. I've got some doubts. So, yeah, and that's kind of where we find ourselves at the moment. This funny little bar at the top is not just a broken slide. It's actually the temperature in Newcastle from 1850, mapped in lines. So you can see towards the back end how much temperature has risen just in Newcastle alone. I don't know if you've seen, there's a film called Don't Look Up. Anybody seen Don't Look Up? Show of hands? Yeah, great film. If you look at for those who've not seen it, it's about a group of scientists that discover an asteroid heading towards the Earth. And then they raise this. If you change that and view the film from a climate change perspective, it gets quite scarily real where we are presently. So it's a good one to look at that. I got into sustainability. I was saying when I had my doubts about it. I actually came in from more of a critic position. I actually started, I'm a big hiker, so I like to go hiking. And I ended up on Kinder Scout one very warm day. and bumped into a guy who was a ranger up in the hills, and he was watching wildfires, and he was telling me all about how wildfires are big in the UK, and we're going back some 15, 20 years now, and I thought, wildfires in the UK, that doesn't sound right. So I actually started researching it, and that's what actually drove me into climate change. I look at the kind of links between climate change and health, and so when I always start these kind of discussions, what I like to say is, you know, we shouldn't look at climate change in its isolation when we're looking at health. It's a big challenge within health trusts, as we know at the moment. There's budgetary constraints, there's big waiting times, etc. So we add in climate change, and suddenly it's getting a very big picture. There's a few facts that we always like to quote. My favourite one that I've done, and it'd be good to see how many people knew this. The healthcare industry creates 4.4% of global emissions, carbon emissions that is. Did anybody know that one? Hopefully some of you did. It's surprising now, we quote that one every year, at every kind of conference we go to, but it's still something that people find really surprising. It doesn't sound that much, but when you look at aviation and shipping, it's actually more than what they are as industries. So as an industry that is first do no harm, that's obviously something we need to address. The scary ones, though, is when you start looking here, 4.2 million premature deaths globally per year due to ambient air pollution. That's the Birmingham metropolitan area, so that's, you know, Dudley, Solihull, Coventry, Birmingham, dying every year, or nearly all of them, dying every year due to air pollution. When you start thinking of that kind of issue, then it does start to get a little scary. There is a positive note, by the way. This is not all doom and gloom as we go through. There's a measure that we use within climate change, and there's 9 planetary boundaries that we talk about. We have just this year breached the 7th boundary, which is ocean acidification. We've just gone over that. So there's 2 left. When I talk about hope, and there's the QR code. I know Claire likes a QR code, so it was on earlier. You can have a look at the report yourself. There'll be a few of these going through just to be open about the sources. The 2 that we've actually not breached are around ozone depletion and atmospheric aerosol loading, which if you think back when we were all big on aerosols and getting rid of all the CFCs out of them, we came together globally and we created an industry that stopped that. So the hope is we can kind of use that kind of same power to address climate change as we move on. Granted, that is going to be a challenge, but that's kind of where we are presently. One thing we hear in climate change a lot is we can't afford it. You've probably heard that from several politicians that I will not name this year, especially within the UK. This is a document by the Office for Budget Responsibility. So it's not actually my work on part of this one. And it looks at kind of fiscal risks aligned with sustainability. It's estimating that 21% of GDP it would cost to address net zero presently, which is, I know that sounds a bit a scary number, £803 billion. That's actually come down since 2021, so we're actually getting better at it, although it has gone up from last year, so it just shows you that even a year's delay does up the price. One thing that we do look at, though, is where our trajectory is. So we've breached 1.5 about 3 times this year. The projection now is currently that we're heading towards about 3 degrees if we don't do anything, which is a scary thought. Climate change obviously creates a lot of damage, so extreme weather events that we see, and it's estimated, according to this report, again, not mine, 56% of GDP, so £1.68 trillion every year to repair the damage if we don't do anything. So that makes that 803 look a little bit more little. If you add that together, so by 2070, which is where this probably will get us, that gives us £2.2 trillion to address it. So when people say we can't afford it, we can't afford to leave it, is the position we're put on. If we can keep it at 2 degrees, which is what we're trying now to look at, then it drops off 26 percentage points in cost. So obviously the earlier we do it, the better we do it. There is a move now. We've been talking about kind of climate mitigation and how we address that. There is talks now, we're talking about climate adaptation. So if you think we're sat in a boat on the sea, all nice and happy, but you know, the climate mitigation is the holes in the boat. So we're starting to sink a little bit. So the last few years we've been saying, okay, how can we fill those holes? We've now got to the point that the boat's a bit full. So we're looking at climate adaptation. How can we bail ourselves out? So we're having to do more work in this area to move us forward. And that's where we are presently. Talk about the NHS quickly. So this was where it all started for me within healthcare, really. Back in 2020, Sir Simon Stevens produced a report and was the first healthcare industry in the world to push for net zero as an industry, which was a great crowning moment for the UK, something we should be really pleased of. Link to the report if you've never seen it. And it talks about, within here are scopes. I'll not go into scopes, we could talk about these things all day. But most of the scopes, or most of the emissions come from this area, which they have kind of nicknamed the programme NHS Carbon Footprint Plus, which is all about your supply chain and how much they contribute to your overall carbon emissions as part of that process. So when that report came out at Philips, we said, okay, that's brilliant. You know, we've got this, you know, we've been working in climate kind of adaptation within Philips since probably the early 1980s, something like that. So we were really early adopters in that area. But it was like, okay, how do we take Sir Simon Stevens' report and what do we need to do to get there? And this report, which we actually published through ACREM, which is our trade association in diagnostic imaging, there's a link there to the report. And it was published through them because we wanted it to be a kind of not a Philips document. We wanted it to be an industry-wide because it then showed what we needed to do. There's lots of talks about like circular economy, which I'll go through a bit later. But there's also some great facts in it. 125 kilograms of CO2 are generated by each patient per day. That's how much we get from that. So you can see why getting people out of hospital as quick as possible is an important process. And then you look at kind of things like waste and things like that, it gets a little bit more scary on that. 75 kilograms of CO2 per ambulance emergency response. We know how busy ambulances are, so that's another area that we need to kind of look at and address. And the report makes lots of recommendations. It makes recommendations to the NHS, it makes recommendations to NHS procurement, and it also makes recommendations to the industry on what we need to do to change, to go through that. Follow the report, please do. We've just published this year. Apologies, I'm just, wait. So this is the latest report from the NHS, and this is what they've achieved so far. The blue you can see is more like the plus, the NHS footprint plus, and the greens are there is just the NHS footprint. So that's how that's made out. They've made this is the kind of area that I predominantly work in, and they've split that now into consumables and equipment, because that's the kind of areas we're more focused on. To give you a sum of where we've gone since the NHS has started this mission, emissions are down 68% since 1990. 14% in the last 5 years. They're on track to hit their 80% reduction by 2032, which is an unbelievable achievement, and we should really, applaud what they've done there. One of the great ones I like, waste, is one of my favourite subjects, believe it or not. I don't get out much. But waste to landfill is down from 32,000 tonnes to 6 tonnes, which is a massive change in the way that they treat waste. We could talk about waste all day, but I'm not going to, for the purpose of not getting a red card. They've also installed 4,200 EV chargers as well as part of that. So they're well on the way to kind of moving things across as part of this. This is the famous roadmap that as an industry and my work with that trade association, ACREM, I actually represent industry when I do a lot of the work on climate change, working with Department of Health and Social Care, NHS England, Scotland, Wales, and also in Ireland with the HSE. But this is the NHS England's roadmap. We've had these kind of early ones here, which has basically resulted in everybody having a carbon reduction plan that works with the NHS. We're now moving, because we have a kind of restricted carbon reduction plan, so we don't have to measure everything that we do. by 2027, we need to do a full carbon reduction plan. I'm quite lucky in Philips. I did mine when it was the election because I had a bit more spare time working in government and politics and public affairs. So we've actually done it already, which I'm quite pleased about. But it's going to be a challenge for the industry, especially the SME communities, to get that done. So we're doing a lot of work with SMEs to try and get them to that stage. The big one, and the one that's generating quite a bit of arguments at the moment, is this product level requirements. So that's like life cycle assessments. We're looking at every product that is sold to the NHS will have a life cycle assessment, basically. There is a lot of kickback on that, I would say, so that will probably get watered down, I think, as we go through as part of that. The only graphic I've got, so I'll let it run out. When people think about sustainability, the wrong way is usually how they look at it. They look at it as a separate silo. I can understand why people do that. It's quite, obvious, really. But what we're trying to say as part of this process is don't think of sustainability as a separate silo. Integrate it into everything you do. When you integrate it, it becomes part of what you're doing, and then it happens more, and it becomes kind of more of a process flow. So we have it. What we kind of teach and what we're trying to talk about this now is through collaboration. Collaboration is one of our biggest things that we do, and we're also now looking at things like educational pathways. A lot of the people that work in this industry as what I refer to as passionate amateurs. So we've all kind of self-taught. Over the last few years, I've been trying to change that, and we're hoping by next year through ACREM again and somebody from Durham and Darlington Foundation Trust, interestingly, will produce some kind of pathway that we can then educate people, which is more critical than ever in these very geopolitical times that we live in. Selfless Philips publication gratification here. In Philips, we became carbon neutral in 2020, which is one of the stats that we are quite pleased about. It's probably 10 years in front of everybody else, which sounds great, but net zero is not a race that we win on our own. We need everybody to come with us on this, is what we always say. But we have been carbon neutral in our own operations, including business travel and logistics since 2020. And since 2020, we started our first program back in 2015. We run concurrent 5-year programs. The first one finished back in 2020 where we got carbon neutral and 100% of our sites are powered by renewable electricity sources. We also, nothing goes to landfill. I'm not going to go through all these. That circularity is one of the things, going back to that circular economy piece. We have all our products are designed using a circular economy methodology, which I will go through in a little while. And it's probably one of the things that's helping us drive forward. It helps you kind of stable your supply chains and things like this as part of that process. There's an interesting study, if you're interested in helium and MR, there's a very interesting study there. Believe it or not, helium is twice the price of gold now, which is shocking. It's really hard to mine, and that's pretty much the crux of it. There's not a lot of it, but there's enough of it. But it's the mining process that makes it really expensive, and unfortunately we can't get it out. 20% also is in Russia, which, let's be right, we ain't seen that for a good while, so that's eliminated. There are other sources, but the political scene, we've seen issues before where certain neighbours of a certain country got landlocked, so no helium could come out of there, so it all creates issues. Now, what we did in Philips, we designed this new MR. An MR will use about 1,500 litres of helium, roughly, around it to keep it cool. This one uses 7, and it's sealed. So rather than it being open, like all MRs are, it's actually sealed in there for life, so we never lose that 7. So once it's in there, it's never going, and we don't have to keep topping it up, which we do with conventional MR. And when it's twice the price of gold, obviously that's a big expense for the NHS. I'm not going to go into this one. This is about informatics, so this is kind of more software. I know we had some questions in the last round about software as a medical device, I think was the thingy. So this one is about informatics. So this is where you store patient imagery on a server. There's a lot of talk about this, both with AI and things like that, and servers, cloud-based. One of the things we do at Philips is we have a green coding community. So what that just tries to do is every time we write a piece of code, it will use so much energy, but you can write it a different way and it will use less energy. So we always ensure that every piece of code that we use goes through that process, so we're using the least amount of energy as we can as part of that. And there's some achievements there just about cloud-based and things like that. So I talked about circular economy earlier, and this is probably the one slide that kind of covers that. There's a bit of a mindset change around circularity that we need to address within the industry. But what circularity tries to do is we try to eliminate this, it's called a linear purchasing cycle. So the way that we buy anything pretty much these days is you'll take a raw material out of the ground, you'll make a product, you'll sell it to one person, they'll use it, they'll throw it away, we start again. So what circularity tries to do is kind of chop those ends off. So we're not using raw materials as much as we can, we're not throwing it away, we kind of keep that process in the middle. And what we try to do is capture as much value and eliminate as much waste within that process. When we do that, and we keep that kind of asset at its highest value, that's good for us, because once people have said, okay, I've done with that piece of kit now, I need something else, we can then reuse that somewhere else in, say, a lesser industry, maybe veterinarian, for example, or something like that. So it really does help us to kind of move forward as part of that process. That's a very brief kind of circular economy. You can do whole qualifications in if you do, but that's one of the ways that we're looking at it. And the other one is, it's called circular addition, but it actually means refurbished equipment. The one thing that we need to do within the NHS is start in a way to move from the shiny toy syndrome, as I call it. So the new, everybody puts on a tender, new, straight away, automatically, don't even think about it. We need to really break that process now, moving forward. And that's just a bit about refurbished kit. So ultimately, you can save on average about 80% of the average weight. So you can imagine from a carbon footprint, raw material state, that's quite a big impact as part of this. Also, and this is another one where I can't get my head around it, on average, it's 25% cheaper than a new piece of kit. We had two ultrasound pieces of equipment that we took to a trade show in Europe a couple of years ago. One was new, one was refurbished. Same software, looked exactly the same. You got the same warranties, you got the same service cover, same lifetime, but one was on average 25% less than the other one. And the challenge was to guess which was which. And it was a ball tube voting kind of system, and there were 50-50 by the end. Nobody could really work it out, so they were just guessing in either. And we had like EBM communities in there, which, you know, they gave it a big going over as part of that process. So it just shows you that, you know, that is possible. Oh, I'm not going back to the wordy slide. So yeah, just going back to the kind of collaboration piece. So this is just about what we can learn as an industry. So best practice sharing, sustainability assessments. Durham and Darlington, we did a great one that actually got mentioned in the House of Lords, the study that we did. We looked at their ICU department and we said, okay, what do you want to do with it? They said, reduce waste, reduce the carbon footprint. ICU is notoriously carbon heavy and waste heavy just because of the emergency medicine that it is. And we managed to do that through an assessment we did with them. And lessons have then been learned that we can transfer to other trusts as part of that process. I'm going to end on this one, just because I did an interesting study. So who believes that smoking can cause cancer? Hands. Yeah, we all believe that, don't we? It's pretty. Back in the 50s, in fact, even up to the 90s, believe it or not, there was a lot of rhetoric that smoking didn't cause cancer, and the tobacco industry really kind of created this new model of kind of PR-driven, where they kind of tried to challenge the science. Now, let's be right, where have we heard that just recently? So there's a few here that, sorry, go back. A few here that are classics. I'm going to start with our friend. Where is he? There we go, our friend down here. Global warming's a con job. It's a green scam. Of course it is. I'm not going to mention the Guardian article that he asked for $1 billion for his campaign from the fossil fuel industry, but that would probably be liable. But it was a Guardian article, not mine. But if you look, PR had sowed doubt in the kind of that smoking and cancer was linked. So the Tobacco Institute kind of launched that campaign when that statement came out. There's no such thing as consensus science. If it's consensus, it isn't science. So tobacco used it all the time, that it's not proven, etc., etc. So in doubt. There's another one here. Victory will be achieved, and these are, you know, some big people here. Victory will be achieved when the average citizen understands uncertainties in climate science. Now, this is the one I think, you know, the industry is particularly, you know, the fossil fuel industry is particularly driving at the moment. Every time you get a question, it's usually some doubt. You get the classic one, you know, well, the Earth, you know, it's always warmed up and cooled down. When you go into the depths of that, you know, there is good scientific evidence of why that's happened. When it did go up and it did get really warm, it wasn't a great place to live, I can tell you that. And lots of things died out. So we're trying to avoid that. And we have the chance. Back in COVID days, we had an R number. I can't know if everybody remembers that. And it was how infectious things were at the time. We work now within climate, and what we're trying to do is, and this is a great example of educating people and collaborating with people. And what we're saying is, if we have an R number of 7, so if I can just convince the non-convinced at the start of this, that this may be true, climate is an issue, and it is actually the biggest crisis facing us presently, that if you can go away and tell 7 more, then that suddenly becomes a whole movement that we can get behind and start to change this rhetoric. And that's, you know, if there's an ask for today, that is the ask I'm kind of pushing. But the links, you can see here where the tobacco industry kind of PR machine and the fossil fuel industry is very, very well linked in their approach to climate change, which is really, really an interesting approach. I've got 5 minutes, so I'm presuming that's with questions as well, so I'm going to quickly go to that. So if you've got any questions whatsoever, there's my LinkedIn there. Feel free. I love a skeptic, and I love a question because it challenges me sometimes. Some people ask me some great questions. I think that is a great question. I've never thought of it on that point of view. So please feel free. I've even put the phone number up, and that conscious that, you know, I'd love to address this. So yeah, that is kind of climate change and health in a nutshell, and I welcome any questions. Lucy.
Thanks, Chris. That was a really, really interesting talk, and it's really helped me understand more about the concept of sustainability in healthcare, because we were talking yesterday, weren't we? And I think sometimes it's not clear what that means. The thing I've been thinking about recently a lot about is the sustainability of using AI and the emissions that can come from that. And I didn't know if you could give any comments on that, please.
We've got an expert actually in the panel soon on AI, but I'm sure Estelle can tell me a lot better. But yeah, AI is a great one, to be fair. So if we go back to the MR, for example, the MR is the biggest consumer of energy in any hospital. It's about, for our Dutch friends over there, it's about 27 Dutch households per MR of energy per year that it uses. It massively consumes energy. What AI can do in that process, built into the machine, it can reduce that scanning process. So if we reduce the scanning process, that's where all the energy is being used, basically, in MR. So if we can reduce that process, and then if we use kind of the green coding part that I've told, that will help us reduce energy use. When we look at AI as a whole, you have to look at then at data centres. You know, there's a lot of talk about data centres these days. If you're not aware, there's a £4 billion one in development just off the M25 presently. And they're looking at kind of their impact. So an AI, when you start looking at it, it's not just kind of energy use, it's water use. I think it's something like 6 cups of water to use ChatGPT, I've heard just recently, which is quite interesting. That's every time you use it, by the way. So, yeah, use it sparingly. So, yeah, there's a water aspect. And so what they're doing is they're using air cool as part of it, so to get away from water. Energy use is a big one. In Dublin, for example, and Ireland generally, we've had a lot of issues with blackouts or potential blackouts due to energy consumption from data centres, to the degree the Irish government are starting to kind of restrict data centres. Data centers have actually come back at this, and they're starting to kind of build some kind of on-site generation mechanisms. Obviously, renewables is the obvious way to go forward. In America, AI is a big issue. It's expanding so much, they can't actually generate enough electricity now to cope with the demand. The generators, unfortunately, they're still using gas generators in America. There's one provider there in America that his waiting list is something like 12 years now, because they just can't ship these things out quick enough. So it is something we look at. Obviously, renewables is a good thing, but also biodiversity is another area we need to address. You know, you can't just stick these data centres in and consume all the resources in that area. And again, the one is on Sky News. Have a look at the 4 billion. So again, I'm not quoting anything that's mine per se, but they've integrated really well into their environment. So they're actually maximising the biodiversity in that area and actually building it up. So it's a great example of where AI, sorry, that's a really long answer, Lucy, but it's a great example of where AI done properly with data centres can be properly used, but also there's a lot of negative ones as well. Have we got time for them?
Hi, Chris. Thank you. I was wondering, from the point of view of horizon scanning, we often look for the shiny, new, innovative medtech. When something is in this cycle of recycling, repurposing, how can we distinguish something that is new? Because, you know, the helium gas was a good example. What sort of signals should we be looking for? So we know it looks the same machine, but actually it's got a huge cost-saving implication, so that's innovative in itself. What kind of signals should we be looking for it?
It's a good question, and yeah, a difficult one to answer, because a lot of it is just, a lot of medical devices get chosen on personal choice. You know, it might be Philips, it might be Siemens, it might be GE, that's one aspect they will look at. Nobody looks at refurbished at the moment in the UK market anyway, which is what we need to change. But maybe, you know, one of the things of integrating sustainability into everything you do is, and I work very closely actually with the Royal College of Radiology. I helped set up their sustainability working group with Kaiser Malik there. And one thing we're trying to look at is kind of making sustainable choices. So when you're looking at your kind of case of, you know, what's my business case for a new piece of medical equipment, you know, does a sustainability refurbished piece of kit suit that better than a new one? It depends on your demand, I suppose. If you've got something that's, you know, going to be really high demand in there, then that may push you towards new. If it's less of a demand, that might push you towards the refurbished, but that's not necessarily so, because, you know, some of this kit can go, you know, can go just as well as the new stuff. What we're trying to stop is this single-use piece, and that's what we really need to really eliminate as quickly as possible. We've got something like 6 years worth of carbon credits left from fossil fuels, so that means we can burn fossil fuels for about another 6 years. After that, it starts getting a little bit dodgy, for want of an understatement. So, and this is not going to be us in this room, but it's now looking at our kids and what they're going to be having to address as part of it. And it is one generation away now. We are that close, so we really do need to start acting. It's not, you know, people talk about we need to, this is the decade of action. It's not the decade of action. Last decade was the decade of action. We're a decade behind. We really just need to step up. And the ask is that, you know, take this away. Somebody says we can't afford climate change. Refer them to that report. Great question. Yeah. So we have, sorry, you've got me again. You can't get rid of me now. I'm here, I'm not moving. So we've got a panel coming up now. If I could ask everybody to come up. There is 4 members of the panel, but we may be missing one. Just coming later. We can make a start, so it's not a man. So while the panel comes up, I'll give you the brief of what we're looking at. Please, guys, stay up. It's 2050. You guys have done a great job. You've took on board everything I've told you. You've written to your MP and said, I'm really concerned about climate change. You've changed your bank, because HSBC and NatWest are massively invested in fossil fuels, so we've decided I'll look at ethical banking, and I'll move away from that. So all these actions, there's other actions I can tell you about, but I won't lecture now. We've got to 2050. We're controlling emissions, so it's all looking good. The health and life sciences landscape looks dramatically different, though. More data-driven, more sustainable, yay, more connected, but also more complex. What could a more equitable and sustainable health system look like, and what does it take to get there? From the use of AI, automation, integration of sustainability as a core health value. What could the breakthroughs, policy shifts, partnerships be that reshape health and care between now and 2050? And that's where we're looking, so we're zooming forward. So firstly, I'm going to just ask the panel to introduce themselves. Sure.
Okay. Yeah, my name is Shola Idowu. Run a biotech company based in the Biosphere, Newcastle. We've been going for about 12 years. I came to Newcastle 30 years ago for my doctorate degree, so I've not left the university, I'll say. Yeah, it's great to be on the panel. We work in the beauty and personal care space, an industry that consumes a lot of materials that are not necessarily sustainable. So yeah, looking forward to the panel.
Sure. Estelle?
Yeah. Hi everyone, I'm Estelle Blancs. I'm the Director of Business Development and Enterprise here at Newcastle University. So what that means, in a nutshell, I look after everything to do with commercialization, the creation of new companies and spin-outs from this university, our strategic partnerships with industry, and everything knowledge exchange. Two things, I'm really delighted to be here. What a great topic to discuss this afternoon. I am absolutely not an AI expert, and I want to mention this. However, I do work with people who are very lucky to have a Centre of Excellence here in this university in AI, which I'll talk about. And the second thing, I've been in this role for 18 months. There's still a lot to learn, and hence why I've got some notes.
You're not the only one. Christina.
Me too, by the way. I have some notes. Lovely to meet you all. If I haven't met you before, my name is Christina Blood, and I'm from CPI. CPI stands for Center for Process Innovation, and we do innovation in medicines manufacturing, in medical devices, in sustainable materials, in biotech, and a lot of other things. So we are part, if you haven't met CPI before, we are part of the government's Catapult, basically a network of labs, full of expensive and very, very cool equipment, and also manufacturing spaces. And we have scientists, engineers that can operate those machines. And we are in the ecosystem to support SMEs and innovators bring their awesome ideas into market. So we are there to help. That's our main goal. So if you haven't met me before, hopefully you can come and meet me after the panel today.
Thanks, Christina. I'm going to start, Christina, with yourself then, since I've just been an ex-engineer. I always like to hear about new technologies. So CPI has been at the forefront of RNA and gene therapies through innovation, through innovative manufacturing. It's 2050. We're there. You know, it's all good. You don't need to see my references, by the way. It's 2050. How do you see personalised medicine reshaping patient care and prevention?
That's a very good question. Personalized medicine can be seen from so many different points of view, I suppose. And at CPI, and at least for us, it means genetic personalized medicine. Personalized medicine that is made for your specific genes and whatever defects your genes might have. So we work a lot with innovators in the RNA space and mRNA space, and also in the oligo space, where we help develop medicines to target specific diseases, some of them rare diseases. And in the future, I hope there is still a few things that need to happen for this to become a reality, and definitely bespoke genetic medicine in 20 years, in 25 years, I think it will be a reality. And if you follow us, you might have heard that we have an RNA Center of Excellence where we will have a biofoundry, which is basically our attempt to manufacture those types of medicines at the patient, as close to the patient as possible, and bespoke for the patient. So on one hand, you have that, which is genetic medicine made bespoke for the person, but you also have things that we work on. For example, pediatric doses, because there are not many pills made for children. So you normally have to break an adult pill to administer to certain patient populations. So CPI works also in developing ways, mechanical ways, and more automated ways to do that type of dosage. So not only in genetic, but also in pediatric dosing and all other things. We work in personalized medicine. It depends on where you look at it from.
Yeah, it's certainly I think it's an exciting area to be developed, especially when you're thinking about kind of antibiotic resistance and things
absolutely,
like that.
Absolutely, and microbiome. We also do microbiome therapies, which again are so bespoke to the patient as well. Yeah.
Yeah, good one. Thank you. Estelle, I'll come to you next, if I may. What initiatives, both regionally and nationally, do you think that have potentially transformed in the past 25 years to get us there? What health innovations would we have seen? Yeah. So, Chi, welcome. That's okay. You're a very busy person, so it's great to have you here. We've just asked everybody just to do an introduction, if you don't mind, just for those who don't know you.
Sure. So I'm Chi Onwora. I'm proud to be the Member of Parliament for the University, for this site, for Newcastle Central and West. And I also chair the Science, Innovation and Technology Select Committee in Parliament, whose responsibility, whose duty is to scrutinise and assess government policy and delivery on all things science, innovation and technology.
Great, thanks, Chi. So, Estelle,
yes,
do you want me to go through that again, or you're
no,
okay?
I think I'm... So you've asked us today to kind of project to 2050 and think about, innovation. And I started the reflection on paradoxes, really, because you talked about fossil fuel. At the start of the Industrial Revolution, fossil fuel was the obvious answer to progress and growth. So how do we make sure, looking at data and AI, and specifically is what I'm focusing on here today, how do we make sure that this is what is an obvious answer today is not creating the problem in 25 years' time? We've heard throughout this conference really about some of these issues around data and data provenance, and therefore, how as we become more digital, how do we ensure we don't expose ourselves to all sorts of risks that are already emerging in some places? When we look at AI, how do we ensure that safety and responsibility is introduced in AI and AI versus people? And the other thing is digital literacy and access. How do we take into consideration geography, age, socioeconomic status, and make sure that we bring everybody along with us on this journey and be inclusive? So, of course, as a university representative, we absolutely believe that innovation is an answer to all of this, but we need to ensure that we do this responsively with in mind those kind of progress paradoxes. So some of the things that we're doing as a university is obviously research and education infrastructure in all things data. We've got obviously fundamental research in computing, mathematics and statistics, and also we're developing the next generation of skills for data and AI through the National Innovation Centre for Data, which actually sits in this building. We've got a new Centre for AI Safety, really important in relation to the paradox I've just mentioned. Colleagues are working to ensure that our AI systems operate safely, ethically and reliably across all sectors of society. And of course, we're also leading on the National Edge AI Hub, And edge AI is an interesting concept because it's looking at AI at a point where data happens, so Internet of Things, devices, sensors, etc., which obviously have a huge potential within the healthcare process. So that's just a small selection of some of the things that are happening here that can get us to that 2050 in a way that is inclusive and sustainable.
Yeah, no, it's that safety, ethical argument within AI is something obviously a lot of people, quite rightly, have concerns about. Funny enough, one of I'm a big favour of podcasts. There's one called The Real Zero. It's not mine. A shout out to that one if anybody wants to see that. And they mentioned about rogue AI and what happens when AI goes rogue. And they actually made the similarly to the fossil fuel industry, saying that rogue AI is a lot like the fossil fuel industry. It's got an objective to make money, and it doesn't look at the other aspects that it affects. It just concentrates on that, and that is, I guess, one of the things within AI that we need to make sure we don't replicate as part of that. Shola, I'm going to come to you next, just she a bit more of a she can hopefully rest before I'll get to you the next time. What is SMEs? We've heard SMEs talked about before. They are a big part of the NHS kind of supplier footprint. What's the role of the SME in transforming future-focused insights?
Yeah, thanks. A really good question. So SMEs they're motivated by profit. And that drives their intention to bring the future into the present by creating solutions that will drive the technology of the future, whether into services or creating a new set of products. And what drives the SMEs is the human need, the human consumption. NHS is slightly different because it's very specific as to what the requirements for the innovation is. For us, working in the wider industry with the beauty and personal care, I'll probably say majority of us have used like 10 different products today before coming here, whether it's in shampoo, conditioner, aftershave, toothpaste. Those are one of the biggest consumers of carbon, on the planet, and they use the amount of energy to produce those products. So the future that we're going into is about using AI to create smarter, more efficient, more personalized products, less waste because we're having the right materials, the right products that is beneficial to the, maybe a particular ethnicity or group of people. And I guess that is going to drive medicine as well in terms of developing personalized medicine. But on the wider scope, I mean, United Kingdom is still a small island. We're talking about the globe that produces more greenhouse gases and more emission bigger than the UK. So the role of the UK to be able to lead the other parts of the world in innovation, in ideas, and offering solutions for their own problems as well is going to be the thing that we need to get to the future that we aspire to.
Yeah, I think the SMEs involvement in anything moving forward is such a big piece of every discussion. And harking back to one of the previous callers, making sure that everybody has that voice and everybody's included in that process is an important factor. Thank you, Shola. Chi, I'm going to come to you now, if I may. So it's 2050. Over the last decade or so, the UK has tried to balance rapid technological innovation like AI, automation, genomics, with a need for kind of strong public trust, that ethics piece that we talked about earlier. What would you think are the kind of pivotal policy decisions, frameworks? What have we done to get there? What do you think the kind of technology developments in a safe, ethical equitable health system would look like?
Well, that's a huge question. It's a really good time to be asking that question with the Labour government dedicated to digital transformation for public services because of the benefits that can bring, and also particularly for the NHS as well. And I suppose I want to really just start with the NHS, because the NHS was brought into being by a Labour government after the Second World War. I think it was one of the most transformative advances in health equity in this country, probably the most transformative advance in health equity, and that was why it was brought into being. It was brought into being to deliver more equal health outcomes. In the poverty and the 30s and the 20s and the 30s, and the way in which health became something that was a matter of what you could afford. That was transformed by the NHS, and it still is. It's sort of raison d'etre. It's not perfect. There are challenges, but that is really what it's for. And if it's to maintain that mission in 2050, it can't go on as it is, because the health challenges change and the technology opportunities change. And I'm not simply talking about Elon Musk looking to live forever, or some of the other. But I'm talking about some of the things that about the opportunities. Estelle was talking about the opportunities for better and more personalised healthcare. And I think that the first thing that we have to do is recognise that this is something that we can do, and I think that is almost in itself a challenge, because if you listen to some of the tech bros, and if you listen to the Conservatives or Reform or whatever, you'll get the impression that technology is something that happens to us, that that it's the market, and I should actually probably do it. Declare an interest in that. I do use Shola's hair products. I recognise the contribution that the private sector can make to all our well-being. But as Shola said, the private sector is looking for profit, and that's the way it works. So to recognise that the state can shape the impact of technology on people, and specifically on the NHS, to recognise that is the case, and not sort of throw our hands up in the air and say, oh, it's all going to it's just going to come and destroy or change everything. We can take decisions that do shape that impact, and some of the you must stop me, Chris, because I could go on about this forever. So I'll try to. Some of those decisions are just for example, is to have the AI Security Institute, which looks at some of the making sure that frontier AI is understood and potentially regulated. Some of that is in the regulation around AI products and services. Some of that, and I think this is part where the real challenge is. We need the NHS is slow at driving innovation out into people's lives. It's slow in comparison with other countries. We're slow at getting great innovation to patients. Partially because of all the different health trusts, partially because NICE is very good at trying to get value for money, etc. So we need to drive innovation more quickly, but we also need to make sure that it has the patient voice in it. It is part of the design and the practice of it. And so that's that's one of the when Wes Streeting talks about the shift from analog to digital, and from ensuring that people's voices are there to shape some of those technologies. And if you look at whether that be online access to doctors' appointments, or whether it be whether it be like AI scanners, which can identify issues with can flag issues with scans, etc., more quickly than humans can, but will still be verified by humans. So leaving radiographers to be able to do more, to be more productive, but without taking humans sort of out of that. So I think that the key answer to the question is to make sure that the patient and the voice is part of it, and the practitioner voice, and to put as much as possible control in the hands of patients, of users, of the public. Oh yes, and transparency. And sorry, another thing is also sovereignty, so that these services, are being developed in the UK, preferably by UK companies who are answerable and accountable to the UK.
Yeah, that is a great point, to be fair. I know certainly from kind of an AI perspective, there's kind of a lot of focus on it, probably. I don't know if any of you watch the Gresham lectures. There's talks about whether kind of radiologists, so these are the people that reports on the images we create, will be kind of phased out from an AI perspective. But
no.
Yes, that's what I was going to say. We like to refer to not artificial intelligence within our industry now. We tend to refer to it as augmented intelligence, that it has that human step, because I think that is a crucial one. And ultimately, it does grow Britain and British jobs as part of that. So a great point. I'm going to open up the audience at this moment. I have got some more questions, but I'm sure there's a lot of you in here that may have some as well. So if anybody has got one, if not, I will ask some more.
Thanks. Hello, everyone. Rich Murray from the UK Health Security Agency. We do a lot of the research that backgrounds some of the air quality stats that you put up in your lecture, Chris. Just thinking ahead to 2050 and the impossibility of knowing up to sort of 2050 o'clock when it comes to the rate that AI is developing. What role do you think AI will facilitate outside of healthcare settings in the future? So I'm thinking specifically that we have a Centre for Climate and Health Security that works with a lot of local authorities to put in climate adaptation measures in public spaces, thinking about how healthy living will take place outside of clinical settings in the future. I just wonder if the panel have any reflections on that.
I'll start. Cheers.
So I mean, it's a great question, and I think that AI is transforming our lives outside of clinical settings. So there will be a consequential impact on health and well-being, whether it's monitoring your exercise or actually monitoring your sugar levels from medical devices. As part of the committee sort of looking at digital transformation, we heard from a local authority, I think it was Surrey Local Authority, where they had AI monitoring elderly living at home, and would be looking at things like, there's a sort of surveillance aspect to this, but looking at, had the person made their cup of tea at the usual time in the morning, they'd make it, and if they hadn't made it, then maybe there was did that indicate that they might have had a fall or some sort of something in the night. So I think there's a lot that I think the privacy and the security aspects of it need to be got right, and that needs to be part of the design. But there's a lot of that AI can do in terms of personalized understanding of lifestyles and treatments. We had on my committee every week we have an innovator showcase what they can do. In fact, Shola was one of our innovators. Yesterday we had a company called Humor who say that if a GP tells them what medicines you're on, what health challenges they are on, they will design and immediately an app, a personalized app, which will tell you what you should be doing or what you could be doing every moment in order to, as well as reminding you when to take your meds. So I think there are huge opportunities there, but as with all technologies, we need to ensure that it's shaped to reflect, you know, the needs of people and is under the control of people. And I always say, if it's not diverse by design, it will be unequal by outcome.
Yeah. So I think what I will add to what she said is that, you know, separating the data from the AI itself. So I think what you are describing is the ability for us to be able to get more sensible, actionable data. So the benefit that I see for the future for 2050 is the ability to create stratified solutions that meets different requirements. And the AI sits outside of that. It brings in the solution that is so targeted and so personalized. Say, for instance, if air pollution is a problem in Newcastle or noise pollution is a problem in London. So rather than having one policy to deal with both, we probably could have more targeted solutions that can actually, you know, fit into different ethnicity or different groups, depending on how different people respond to the problem. So I think we're going to see explosion of data, which is very exciting because that is one of the ways we can create inclusive, stratified, you know, solutions to, you know, to everyday, you know, problem or medical problem as well.
Yeah. Oh, I don't know. Yeah. So if you're talking about applications outside of healthcare, I think two things. I mean, in this university, you know, we're looking at all sorts of projects at the moment, including use of AI for water contamination analysis, and therefore avoiding contamination in humans. You know, and we use some of our expertise to contribute with some of our industry partners to this huge challenge, actually. And I would also invite you to have a look at some of our spin-outs that, you know, demonstrate some of the, you talked about personalized medicine as a kind of use of AI. A company called Nuna Bio, sits here, not on the Catalyst, but the Biosphere building, is looking at this very issue, looking at AI as examples, and there are, as we've heard, many others.
Christina, do you want to add anything?
Maybe I'll just add something from the manufacturing point of view. We look a lot of processes to manufacture medicines, but we also look at processes to manufacture paints and all sorts of other things. So in the processes, normally you go stage one, you have a pan where you're mixing different liquids, then goes to another pan when you're doing something else, in a simplistic way, of course. But the thing is, in the processes, the different process units are not speaking to each other. And so the processes are slow, and they are still paper-based. They are still, and so AI is going to revolutionize the manufacturing world, because you have to go through a digital transformation journey, that is for sure. But we are still in the manufacturing spaces at early stages, because everyone has their batch numbers and their batch, the quality papers all still on paper. So you have to go first to a digital version of that, and then you have to get all the digital versions talking with each other. And then on top of that, you get AI to interrogate. Where can I make my process quicker, better? How can I increase the yield? So it can revolutionize not only, you know, the production of medicines, of medical devices, but also the production of paints, of whatever you can think of.
Yeah, I'm going to jump in. I'm going to pull chair advantage. So yeah, it's a great question. If you look at kind of where we are now, there's these necklaces that you can wear that are kind of AI that will kind of interrogate your devices that you're wearing, and will automate a lot of your day-to-day processes, so streamlining things like that. You look at biodiversity, you look at woodland management, with drone kind of AI technology that we're looking at that. Biodiversity is such a big part of our lives and very integral. And that's one of the things, that kind of planetary health, human health is so linked that it's well established now. But that biodiversity has such a positive effect on people's recovery, it's untrue. It also plays a part into that preventional piece as well as part of that. And touching on Chi's point on that kind of movement of people within hospitals now, we're seeing these digital twins being created, where they can kind of look at patient flow through hospitals, so they don't track the person, the track movement through hospitals. But we also now, and I was at a conference last year where we were discussing this, and there was a lady on who was a community nurse, and she has a sensor in her mum's house that tracks her movement through the hall. And she knows that, she's pointing, that if she's not going through the hall at certain times, usually after coronation's finished, she always makes a cup of tea, like, you know, but that is the way that, you know, it's being used outside the home. And I think that kind of process, there'll be more on that. You know, we're looking at wearable tech and the development of wearable tech, that's, and I purposely didn't touch the 10-year plan, that community to, you know, hospital to community, prevention to illness, etc., but that area, you know, is another big area. We did some work with the Imperial on one CT scan, the carbon footprint of one CT scan. 60% was patient travel. So eliminating patient travel, putting things back into community, CDCs, community diagnostic hubs, etc., is a way forward, definitely. Anybody else? Thank you.
So we talked a lot today, haven't we, about all those kind of opportunities, and as a absolute frontline clinician, and also kind of I'm one of the GIRFT national leads as well, the kind of the technologies in the NHS are hugely important around the 10-year plan, and having used augmented technology, so we've currently got a digital assessment routing tool that we're going to talk about in a little moment. So all the usability studies have been done. We've kind of had fabulous patient engagement, because I think throughout some of the talks today, I've only been here today, I wasn't here yesterday, unfortunately. I think sometimes we've lost that kind of patient focus. So we've talked about clinicians, we've talked about technology, but what about those people who are actually using it? But I suppose one of my asks to the panel is, it's a challenge to get some of these things through. So the research is there, the data's there, we've proven it to work. It's business as usual in some of our organisations, yet there's barrier after barrier after barrier. So how are we going to reduce that?
That's a great question.
Yeah.
Charlotte,
I think, I mean, what you're saying is absolutely amazing and spot on. You know, there is a need for a cultural change in the way we design patient care, in the way research is done. What AI is given to us is the ability to handle vast amount of data, very complex data, in a way that we can process them easily. Research inclusion should be at the start of every project or every care plan or every strategy, you know, to improve the system. But that cannot be done in silo. It cannot be done because we said, oh yeah, we want to research inclusion, we want to make sure it's representative. We need to talk to the people that are affected. We need to engage with the stakeholders. The people that are going to benefit from the process needs to be aware of the solution that is being designed for them. I think with that, because we have AI to handle the data now, we can now increase the amount of complexity that, you know, in the analysis that we can do, get more actionable data and design better systems that is necessary. So it's more of a cultural change in the mindset that there is something called AI. It allows you to handle more complex, more challenging data. So let's go for it. Let's get as much information, as much complexity into the process and build a model that can solve a particular problems, you know, with the stakeholders involved.
Yeah, I mean, this is a really good question. And I think if we all had the answer, perhaps we wouldn't be sitting here today. But I think there's a couple of things. There was a talk earlier, I think, by yourself on design thinking and the concepts of co-development. And I think, I'm, again, not an expert in this, but this is something that we've been looking at here in how we do innovation across the board, starting from real well-designed challenges that we can then involve all the stakeholders that need to be involved in resolving that challenge, not just as a kind of technology push approach. And I think we've heard quite a few good examples of this being developed. I think the healthcare and life science environment lends itself well to this, and yet you're saying, you know, from your experience and many others, that this is still not obviously still meeting lots of obstacles. And I think it's because we need to collaborate more, involve all the key stakeholders of aligned to a particular problem from the outset, and not have this technology led. But there's probably a lot more detailed answer to this.
Christina, do you want to add anything?
So just to be clear, we're talking about diffusing innovation in the NHS.
So it's when we've done kind of that service transformation. So we've used that augmented kind of technology. It's been proven, it's got the research behind it. Right. But to then get that kind of pan ICB, you're meeting governance challenge, you're meeting finance challenge, and you're having to constantly prove whilst also delivering activity, seeing the patients, even though it's evidence.
As I said earlier, that the NHS is not good at diffusing technology. It's not good at taking up innovation and delivering it to patients, and that's a really big, significant issue, which I know the Secretary of State, Wes Streeton, is very sort of seized on, because he can't make his productivity and other improvements unless we do fantastic science. We've got wonderful researchers, and we've obviously got fantastic clinicians as well. But unless sort of innovation is adapted through the system, it doesn't make the difference it needs to make. So, for example, so I know that Wes is looking. I think we're trialing passporting new processes or new innovations from one health trust to another, so it doesn't have to be approved by each separate health trust. There are trying to, so there's a cultural thing, but it's very. This is why the workforce plan is important as well, because, I mean, forgive me if I'm telling you what you already know about, but if everyone's overworked and under-resourced, then then trying new processes in a new innovation, even if you know it's going to bring benefits, just finding the time to get to do that can be really challenging. And then there are sort of disincentives around how things are funded and where the benefits might go through, which there's been examples of health trusts that have tried innovative ways of looking to address that. There's also, I think, there's also issues around approvals, regulatory approvals, and I know that MHRA is looking at how, particularly when it comes to sort of medical tech as well, rather than treatment, sort of medical technology, to make that quicker. And the Regulatory Innovation Office is got to focus on healthcare, which is trying to look specifically at removing barriers. But another way is to write to your MP and tell them to raise it with the Secretary of State.
That's the second time we write to the MP. Yeah, it's a good question. And to be fair, and from a supplier perspective, and the suppliers I speak to, it's equally as frustrating from our side as well. We do, we see that it's kind of NHS England, DHSC kind of vision, but then at the trust level, it can, we can choose what we do. Evergreen's a great example. Evergreen, if you're not aware, is a platform that as suppliers to NHS supply chain we have to complete. It has 5 maturity levels, no score, 1, 2, 3, 4. 4's the highest you can get. There's a handful of us have got 4. I'm going to hold my hands up. That was the one thing we did this year. We were the first health tech company to achieve maturity level 4. That's Philips advertisement, sorry. But the trusts don't have to use it. We were part of the pilot. It took us 6 months to do the initial pilot, to compile all the data. There's something like 244 questions within this pilot, within this document. It's got better as the year has gone on. Lessons have been learned. Within Philips now, we can do it in a month. It takes us a month and a project plan to complete it, but trusts don't use it. It's quite frustrating, and all the data. NHS supply chain use it. It's brilliant. They produce so much great data out of it. But at a trust level, it would save so much admin. It's an easy win. We're down to 5 minutes. I'm sure we can squeeze one in. If if anybody's got one. If not, I'm going to create one. Right, closing remarks. You've got your wish. You know, what's got you to 2050? Shola, what's your closing remark?
I think it's important to rethink again in terms of processes, in terms of research, in terms of creating solutions that we need to have that inclusion, you know, that research inclusion at the centerpiece, not just, you know, different diversity and ethnicity alone, but also the younger generation. So I have a privilege of, you know, having students over the years at postgraduate level, and I've observed the cultural changes that is taking place, and this new cohort, you know, that I'm seeing coming out from the AI kind of generation, the way they think is so different. I've never come across the mindset and the way they approach solving problems, you know, that I've seen other people do 3, 4, 5 years ago. So including those generation as well in the design process would be quite exciting.
Yeah, that's really good. And it's good to see the younger generation taking that on board. Steph?
Yeah, just building on that is, for me, is collaboration. That's what will get us to that better picture of 2050 and a degree of optimism. I know it's difficult when you see some of the things that you showed, but at the same time, we do have some, you know, great people doing some great work across the board in communities, in universities, and businesses, and collaboration is going to be key.
Great word. I love collaboration, by the way. You didn't realise that. Christina?
I think because we still have time to design the systems to help us get there and to make sure that we are building solutions that are inclusive and that take into account everyone, really. So I would say systems design until we get there, yeah.
Yeah, system thinking is definitely that. And finally, Chief?
Wow, final word. So I guess, you know, what I would want to be looking back on in 2050 is the eradication of the health inequalities, which means that, you know, in Newcastle, depending on what postcode you're in, you can have a 12-year difference in terms of expected healthy life, and depending on what you know, and the sort of the absolute link between income and longevity and healthy living. So, and to achieve that, I think one of you know, we talked about having the patient voice, or having you know, patients at the heart of it. We also need to be, you know, we will have moved from a system where, you know, most of the research is done by and tested on, you know, mainly white middle-class men, to a system where it's both done, you know, it's more diverse in terms of researchers and clinicians, but it's also more diverse in who these treatments and these technologies are tested on and used with, so that the benefits are really targeted at those who need it the most.
Yeah, definitely. Funny enough, we have a bus in Sheffield that goes from one end to the other, and from the start to finish, the life expectancy is 20 years. 20 years. Just on that one bus journey, which is quite remarkable, really, just in one place, and quite scary as well as part of that. So as chair, I'm going to grab the last minute, if that's all right, and just say that, yes, it might sound doom and gloom. Hopefully it wasn't too much, but there is hope. We still have hope. There's a lot that we can do, and working together, collaborating, educating is definitely the way forward. So as an innovation hub, you guys, you know, are pivotal to helping moving us forward. So don't underestimate your own role within that. And if there's no more, I'll hand back to James. Thank you. You can give a round of applause for that.
Yes, thank you again to our panellists, and to Chris, ironically the only one without a chair. We will now take a short break and reconvene at about 1:45. Two things I'd like to impress upon you during this time. One, if you go into the final workshop, do not return here until 3:45. Make your way to the workshop space behind the registration desk. Hopefully you know where it is by now. Second thing, if you think you've already got your favourite talk, I encourage you to keep thinking, because we've got 4 fantastic ones lined up for after the break. If you think you've already got your favourite lightning talk, brilliant, because we will not be going over them again. And if you haven't got your favourite poster already, now is your chance. Go out, check them out. If one of the posters is yours, stand by it, get ready to answer questions, and I shall see you all back here shortly. Okay, everybody. We're waiting for a couple more people to come in, but I think to keep to the almighty schedule, we shall get started. So, moving things right along, it's my pleasure to introduce your first speaker to this final session of FHSC 25, Campbell Lowe. Round of applause, please.
Thank you very much, everybody. So, good afternoon. I'm Campbell Lowe. I'm a physiotherapist by background. I'm a postdoctoral researcher at Queen Mary University of London, and I work for Optima Health, helping to develop, evaluate, and implement their digital tool. I'm joined by Laura Atherton, who is consultant physiotherapist and service lead of the Therapy Outpatient Services at Mersey and West Lancashire Teaching Hospitals NHS Trust. Mersey and West Lancashire have an MSK interface service which integrates secondary, community and tertiary care with approximately 80% of patients self-referring. And they have an average referral rate of around 1,200 self-referring patients a month. I'd like to share with you the results of a quality improvement study that we conducted at Mersey and West Lancs using the digital assessment routing tool, affectionately known as DART. So what it is, it's a digital tool that assesses patients for musculoskeletal conditions, and it stratifies them to the correct level of intervention. So it's not a diagnostic tool, but it does direct the patient to the type of treatment that they need. So to set the context then, it's widely accepted that safe and effective clinical triage is an essential component for a self-referral pathway, ensuring that patients are seen by the right person, right place, first time. So GERF supports not only better patient outcomes, but also improves efficiency and reduces cost across the pathway. But there are too many patients and not enough physios to deliver robust triage, and often services resort to unreliable alternatives. The latest NHS long-term plan that we've spoken about before has emphasised harnessing digital medtech to alleviate the burden on clinicians and reduce the cost of delivering care. But tech in itself is not a magic wand. It needs to form part of pathway redesign. And our study was very much about service transformation rather than just simply putting in a digital system. So this slide shows the existing self-referral process in blue at the top, and the new process that we use for the study in green underneath. So in the previous process, the patient self-referred themselves via a non-clinical Microsoft form on the Trust website, or by a telephone call to an administrator. And they were given the next available appointment with any clinician that happened to be free, and that could be up to an 8-week wait. Now, having said which, 8 weeks probably isn't very much. A lot of services have waits a lot longer than 8 weeks. But the problem is that sometimes patients would go to the first appointment and they wouldn't be included. They didn't meet the service inclusion criteria, so they were immediately discharged, and that was a waste of an appointment. Or they needed to be referred to see a different type of clinician because that receiving clinician wasn't going to help them. Or potentially back to their GP or back to their consultant who needed to review them. In the new process, the patient completed the online assessment, either by themselves or with the help of an administrator over the telephone. And that outcome from the assessment then created a notification to the administrator about the type of appointment that they should be given. And new appointments were created as part of the service redesign. So emergency care routing or urgent appointments for patients with serious problems that needed to be seen quickly, normally within 2 weeks. Routine appointments with different types of clinicians who had the right skill set, and then new types of appointment were created, so self-management appointments, which didn't exist before, and condition-specific appointments like interventions for osteoarthritic knee patients. Collaboration. So this is a word that's been buzzing around the room all day, and it was a truly collaborative study. So between the team at Mersey and West Lancs, Queen Mary and I as the research lead made sure that we had proper clinical governance and research governance around the study. And also Optima Health, who provided the digital tool for free for the duration of the study. So there was input from all stakeholders, including patients, clinicians, administrators, who haven't been spoken about much really, and other departments within the trust, and also local GPs. Everyone was involved in planning, the study delivery, and the data analysis. So this approach has been described as supporting adoption of digital health. And the integrated knowledge translation model is effective in translating research into practice, and is a key factor in any successful system implementation, we would argue. So we used a quality improvement design using PDSA cycles, which is widely used within NHS quality improvement. And this supported the iteration required to safely evaluate the new process in a live clinical environment. So outcomes, this is a brief summary of the outcomes. So we had 3 PDSA cycles over a 4-month period. We had just over 4,000 patients going through, all self-referring, ages ranging between 16 and 104. And our primary outcome measure was patient safety. Okay, so there was 96% agreement between the DART routing and the opinion of the receiving clinician that was a correct routing. And we had no clinical incidents. Secondary measures included efficiency. So obviously the self-referral process was now open all hours, so patients could access the system online if they wanted to at any time of day or night. We had 203 less escalations. So this means that there were 203 patients less that didn't see the right clinician first time. And so they saw the right person first time. And there was a 51% reduction in administration time. This was associated with the process previously of having to make the referral and book the appointment and everything. So in terms of cost savings, that reduced admin time translated to reduced admin costs. We identified 15% of patients that we felt sure that would respond appropriately to self-management strategies, and the cost of delivering self-management is significantly less, so 73% less than delivering a course of physiotherapy. And then our specialist intervention for osteoarthritic knees, again, a small percentage of patients. We just put this in as a tester to see whether using condition-specific routing would potentially offer savings and more targeted intervention for patients. And we used the OA knee as an example because this was a very common presentation in the cohort. Overall, if you put in a physio-led triage service, using the digital tool, we would have saved just over £75,000 per annum using a digital tool and not clinicians to do it. In terms of satisfaction, 84% of patients said they thought the new process was excellent, very good, good, or fair. And most of the negative comments were actually about people who had completed the assessment but were concerned that other people might not be able to do it. 100% of the administrators thought it was an improvement on the process that they've been using before. And the physios were very happy. So a bit more on that then. So something that was really important for myself and Laura as clinicians, understanding the stress that the clinicians are under, having to cope with long waiting lists, back-to-back patients, was the feedback we got from the clinical team, especially the less experienced physiotherapists. So previously, they were getting patients, a lot of complex patients. So complexity really defined by comorbidities and multiple body sites, and also psychosocially distressed patients that require more experience and more, I don't know, time and input than a straightforward musculoskeletal problem. Because DART was able to identify these complex patients, we were able to allocate a certain number into the less experienced physios' diaries. So they were getting 2 a day instead of back-to-back complex patients. And this made a huge difference to their workplace well-being. And just looking at that quote, it was just, great for us to see. And then just in summary, I'd just like you to have a read of these. So this really is vindication of the actual process of what we did, not necessarily the digital tool itself, but how we went about doing it. And just to say that since the study finished, the system has remained in situ. So it's been commissioned, it's been used as business as usual within the service. So it's well embedded now. And these are just comments from senior members of the NHS Trust team. And I think this really just goes to emphasise the importance of implementation, good, thorough implementation, full collaboration and engagement with all stakeholders when implementing any sort of digital system within a clinical pathway. I've left plenty of time for questions, hopefully, because I think there's going to be a few. These are our contact details if anybody wants any more information. The QR code links to the study that we published. It was the last of 5 studies published around evaluating the digital system itself, which included a usability study right at the very beginning, because I know we're going to get some questions about inclusivity. And Dora's going to come and answer the questions.
Hi. Well done. It's really nice to see so many positive outcomes. That's so really well done, really well quantified for us. I was just wondering, in terms of repeatability, what were your thoughts on the fact that locally all your stakeholders designed this approach together and the buy-in was there from the start, and whether this is something that you could lift and plant somewhere else, or whether without that piece, whether this is repeatable or not is probably
Laura's definitely going to answer this one. Yeah.
So it's absolutely repeatable. So the advantage of the DART tool is that, so there obviously is heterogeneity, isn't there, in diversity between individual trusts, even within an ICB. So we have already used DART in its form, but the beauty of it is, so for example, Bolton in Manchester have also kind of utilised this tool, but they've used it in a bit of a different way, so it meets their population kind of needs. So absolutely the foundations, but it can be tweaked to use kind of to support with that service. We're also trying to look at the moment at seeing how we can support the delivery of this across PAN ICB. We're in a really challenging scenario, aren't we, at the minute, where ICB is reducing headcount and all different things kind of going on that are challenges for everybody. But yeah, it's absolutely replicable again in all other services, and to meet the fine nuances in every service. No one service is the same.
Thank you, that was fascinating. One of the things that concerns me around digital is the current discourse in the tabloid press. So, no one cares, there's no human there. And I thought it was really interesting that you said that the negative responses largely centred upon people's concerns that some people wouldn't be able to access the service. This thought has come up again and again over today and yesterday. I was thinking about comms. Have you considered doing anything around communication strategies that explain what you've explained to us? Because I think there is just this, I think services like this are taking such a hammering in the press. And when you just speak to people casually, the perceptions seem to be quite negative, but actually the people that you spoke to, their voices suggest the opposite. And also what you have demonstrated is that it's helpful for everybody. I was just wondering if you'd thought about a comms strategy and whether perhaps collectively we need to think about communication strategies to challenge the current discourse.
And that's absolutely correct, and it is something that we have kind of thought about and had a look at. And I don't know if you heard earlier on when there was the panel, I kind of posed in terms of the challenges that we're kind of all getting, and straight away afterwards I said, right, I'm writing to the MP, so I have a very privileged position in that I have access to some of our national clinical leaders, but actually kind of it's really important that this gets out there. We have developed some slides because it's really tricky to explain kind of the algorithms, and it's augmented, as Chris said before, it's much more augmented, it's absolutely not machine learning, and so it's quite tricky to articulate kind of what it does and how it does it. So we have developed some slides so that they can kind of be up, and I do once a month, I go and sit in the waiting room, which is the most fascinating morning of my month, and go and chat to the patients and kind of how do we have those communications. But yeah, a communication strategy is a fabulous idea. The Director of Nursing's come in to see us next week, and it's kind of on my to-do list, equally going out there to Health Watch. But it's another challenge, isn't it, on top of a really busy day job. It is a challenge, but yeah, absolutely, like you say, that it needs to get out there, doesn't it, so that people can hear about it.
I think if I can just add to that also, yeah, I mean, I think we've touched on it earlier in this session that, commercial organisations are there to sell a product. They're not necessarily looking at solving the problem as such. They've got a gadget and they want to sell it. And they have a lot of marketing budgets. So, you get, press releases and lots of noise going around it. And I think we've taken a different approach insofar as we've tried to solve a problem that we knew existed and worked to solve it with the clinicians rather than creating something we can sell. So, yeah, but I agree, we're trying our best. And that's why we're here today, in a way, and I'm going to the Charter Society conference tomorrow to talk about the same sort of thing to them. And, journal advertisements, Laura's applied for a Health Service Journal Award. So, we're trying to go about it that way, really.
That's what we've got time for.
Thank you very much.
Thank you, Cabela and Laura. Moving swiftly along, our next talk is from Ilar. So, round of applause for Ilar, everyone.
Hello, everyone. My name is Ala. I'm from School of Computing, so I'm the computer scientist finally here. Today was a fascinating talk about AI in the morning, and a lot of people says, where is the computer science think of AI? So hopefully, with my work today, I'd like to show you work that took me like around 7 to 8 years now, and I'm very keen to continue. I don't know how long it will take to have a full impact of it. And the reason I'm here today is to really give the motivations of the work I'm doing from the data angle. So I did the PPIE activities like many of the fascinating projects here, but I'm there working with the data. I look at the data and how to be more inclusive in terms of cardiac monitoring. So I'll speak today about a vision that's starting during my PhD, that we know there are many medications could affect the heart in a really bad way in terms of increasing the risk of arrhythmia and sudden cardiac death. I'll take you to a small, quick introduction about the ECG, or the electrocardiogram. which is something you do usually in hospitals if the doctors would like to monitor your heart, and it's presented as a complex signals. These signals are, as you can see, labeled with waves. Each wave might represent a stage of your heart electrical activity. All of this is just one heartbeat. And it's very complex to interpret. It's usually just doctors and expert clinicians who can actually see where is the problem. The problem we're interested in is a QT interval. It's a distance starting from the Q wave up to the end of the T wave. When you take a medications, unfortunately, many kinds of medications, especially antidepressants, antibiotics, many kind of cancer treatment, could prolong or increase the interval, which is called clinically drug-induced acquired long QT syndrome. Now, long QT syndrome, it's coming from the long QT. It's actually, there is two types. The one that congenital one that you're just born with, and the one that you acquired based on using the medications. It's something that in any clinical trials for new drugs, they test that all the way along, from the early phase trials until post-marketing. But unfortunately, a lot of cases could be known after the drug's been marketed anyway, and then we still don't know fully whether the drug will lead to the Torsades type 1 or TDB arrhythmia, which is a very life-threatening arrhythmia that can lead to sudden cardiac death. So, looking at how the QT prolongation in any hospital, they monitor it. Everyone knows how to monitor the QT, and they need to look at sometimes to the automated numbers, and then they do manual measurement as well, because automated is not very reliable. When we say inclusive healthcare, the way they do it in prescribing antidepressant, for example, or any kind of medications, that prolong the QT. Sometimes even some kind of antibiotics for children. So the way they do it is actually to check your history, okay? Do you have a congenital heart problems? Do you have a sudden cardiac death in your family? They check your ECG, they call it baseline, drug-free baseline. And many things like that, they're trying to mitigate the problem, but the reality is, we cannot really fully be sure that we're mitigating the problem. And many people with a baseline QT can still develop TDB arrhythmia. So when we say inclusive, we're looking at the literature, we found that Black people, for example, have greater than twofold increased risk of developing drug-induced long QT syndrome than the normal or other kind of race. This is like known forever, so we know this information for a very long time. Women already have a prolonged QT at baseline. This is known for doctors, and the way they do it is that they know if the women beyond 470, for example, QTC, that is prolonged, and the men is around 50 to 40-20. And the way they say it is like, if it's beyond 40-70, then it's a prolonged or at risk of TDB. Another study, for example, tried to rule out the gender or take it out, and then look at who developed the TDB or not, regardless of their gender. And they found that if the QT is, for example, with a normal heart rate, 60 beats per minute, they found that if it's around 484, then it's at risk of TDB already. Someone already developed the case. That tells us that the baseline they're already using at the moment is not everything, and it's really missing a crucial like racial and physiology of the human women heart to the men is completely different, and we need to look differently when it comes who's going to develop the TDB. And looking to older people. Age-related and multiple chronic conditions mean polypharmacy. And if we look at the statistic, Europe especially suffer from polypharmacy. And polypharmacy means QT prolongation and developing drug problems. Sometimes all the drugs doesn't have QT prolonging issues, but when they are together, the interactions, drug-to-drug interactions, could develop the arrhythmia. This is definitely leading to think and rethink. And let's have a look to the last year, for example. This is a very interesting study. And when I started looking at this one, it's really reminding me to continue doing what I'm doing. Because when we look at antibiotics or other issues that is really working with infections or something like that, it's completely different when we look at antidepressants or mental health conditions. And with this study, it's in Denmark last year, it's an autopsy-based study that tried to identify from 2000 to 2019 all the cases of sudden cardiac death named as sudden arrhythmic death syndromes, short for SADS. It's really anyone who below 35 years and they have sudden cardiac death, either at rest or while they're sleeping, and they don't know why. They have a completely normal heart structure. And when they look at the study and they do the autopsy base, they found that out of the 477, 313, which is around 66%, had positive toxicology screening results. And most of them were for non-lethal. More than half of these have a positive, which is had QT prolonging or Brugada-like inducing syndrome. So that's mean it's induced the QT or the Brugada syndrome in their heart. This is just tell us that we have to include drugs and medications as a risk factor for SADS. Okay, so this is, how to solve this, okay? So there is many different elements. Now I'll take you to this, which is the work I'm doing now and maybe the next 5 years. And I'm also gonna show you the work that I've done already 7 years before. We have to think differently. So we have to empower the public. We have to increase their awareness, and we have to develop tools that is easy to understand for them, make the ECG, these complex signals I show you, more intuitive to understand, to detect the prolongation early, and they seek help. They can even, at least, they don't take the dose, the next dose. They see that the QT is actually starting to be a problem. I should not take my second dose. I should seek help. That was the motivations behind the first work. And today, I have a much more ambitious one to really detect the susceptibility of a particular patient or a particular group of people before even giving them the drug. I mean, imagine you can have the ECG, a tool in a clinic. I'll take you with my vision. A tool in the clinic, and we put that ECG patient's baseline, and instead of the way they're doing, they just measure the QT, and they do that quick numbers, ruling out, you're fine, you're not fine. They can actually, this tool can show them what's gonna happen. It's kind of forecast to that patient if they took that drug. For example, they can show them how the ECG changed if they took that drug. Fascinating, right? This is coming next to the digital twin that we would like to build. Like, we would like to come to idea that we can actually predict how a patient would respond to a drug. So I had the hypothesis. So before coming to the results, I wasn't really sure, but I had a hypothesis that could be the baseline tell me something. And I started with science, experimental science. You have to focus, you have to control the experiments. I'm not gonna start with diseases, conditions, or people who already have some congenital heart problems. I'll start with completely healthy people, okay? Completely healthy people participating in trials. These trials tested QT prolonging drugs. And they will look at just one factor like race, okay? Whether race can be detected, or race susceptibility can be detected in a baseline, and tell me that these patients could, develop a very dangerous level of QT prolongation. The good thing is we have good trials, we have good data, we have a very amazing ECG that monitor this particular patients over 24 hours taking the dose. For example, half an hour before the dose, and then half an hour after, 1 hour, 1 hour and a half, complete pictures what is exactly happening. And then we can use AI, and we tell, this is the baseline ECG. And you can talk to AI in many ways, okay? You can show them the ECG images, and they take the features, or you can do the measurements, and they give them the measurements. And then we can see, for example, and we tell, for example, each one where they are after 2 hours, 2 to 3 hours, which is the time where the drug is actually concentrated on the heart. It's actually in the bloodstream, so it's really in a good state when we see. I'll show you in a minute. So coming with a very simple initial results, we found that GT peak, which is this area, have a real significant value to show us if this patient is gonna have a QT prolongation. And this area, actually, it's really common with African American people who usually have normal early regularization at baseline. They see it as normal. It's part of their congenital or the way the heart structure there. So this is already tell us if it's a black American man, for example, they should be treated differently when it comes, even if they are completely healthy. I'll show you quickly how I did explainable AI here. So we, as you can see, we used colors to represent what is normal and what is abnormal and make it easy, intuitive to people to just spot by looking to the ECG if this is prolonged or not. So we can see in the top, it's actually prolonged, and the AI can be easier and quicker learning by just looking at the colors. And here we can see a completely normal because it's mostly green colors. And the good thing about this approach is actually adapted and adjusted to heart rate. Something that wasn't possible before. Heart rate to change QT, and people need, clinicians in hospital, they measure it and they correct it to heart rate. But here, completely easy. The colors really tell you regardless of heart rate. At the top, different heart rates, QT is normal. At the bottom, you can see different heart rate, QT is at risk. What's next? We are currently working with the NHS Clinical Trials Unit, and we are trying to see how, in cancer medicine, this is particularly critical because they needed to know if these new experimental cancer treatments can actually do a QT prolongation. So we're working with the NHS to see if we can develop wearables for patients as well as doctors in the clinics and see whether we can discover the QT prolongation early in early phase trials. That's it. Thank you. One minute.
We've got time for one quick question.
Sorry.
I'm curious if you already spoke with clinicians and how they responded on the results of your research.
Thank you very much. Yes, we did stakeholder engagement activities for, I think, 3 years before now. And yes, so the way they see it, it's they know how QT is really disruptive and very challenging things they do. And they really like that they just looking, they know there's a problem. Because the way they do it at the moment, they need to do the manual measurement. And imagine how many ECGs they have in the clinic. And sometimes they don't know, is it prolonged or not? Let's ask the cardiologist. And they bring different people to answer that. And they found it very interesting. Some of the I already speak, for example, in conferences with a bunch of cardiologists and clinicians and FDA and everyone. They found it interesting. And the things they think about it, for example, it could be in ICU, where polypharmacy is there, and the machines are continuous machines. They just want to look. For example, they would just want to see if the red colors is there, so we can stop things earlier. The research I'm doing, I'm trying to really take a step back and really model the whole thing, like what was really happening there. And before it's getting to red, can we have something early on? In baseline, in smaller, maybe subtle changes, or some small subtle changes, and then maybe it's within the orange borderline cases.
Thank you.
Thank you.
Thank you very much, Hala. That was very fascinating. Coming up to our penultimate talk of the conference, please give a hand for a familiar face, one of the IO's own, Pauline.
Thanks, James. Hi, everyone. Yes, I'm a familiar face because I have been comparing much of the last couple of days of this conference. So I'm really pleased that I now get to stand on stage and tell you about my research, which is very exciting. But because I'm a committee member, I just want to abuse my position on stage to run a quick straw poll. So what I'd like you to do is do me a favour and raise your right hand, that's this one, if over the last couple of days you've met someone interesting. So raise your right hand, hold it nice and high, thank you. Keep that hand in the air and raise your other hand if over the last couple of days you've learnt something useful. So there we go, right, oh, nice big stretch, great, now we've had a nice stretch, on with the show. So, I am indeed Pauline, and I'm going to be telling you a bit more about some work that I've been doing with Claire and other colleagues. So hopefully this will be familiar from the introduction that Claire was giving us to the methodology earlier. So it's been in a really interesting field in bioengineering, and we've been finding some game-changing technology in this field. So to start with a little bit of a definition. Bioengineering, it combines biology engineering, and it does what engineering does, which is to solve problems. And it's genuinely one of the most impactful and fastest growing fields in healthcare. And earlier on this year, as we all know, there was the NHS 10-year plan, and this held up bioengineering as having significant promise. And that's brilliant, but we need to know what kind of interventions are out there to know things like, have we got the pathways in place to be able to assess them, for example. So in response to that, we undertook a year-long project to try and identify new game-changing technology in the field of bioengineering. And as Claire mentioned earlier on, we had 3 particular areas to this, and the arm that I'm going to be talking about today is tissues and medical devices. So who was here earlier on? I'm not going to make you put both your arms up this time, don't worry. Who was here earlier on for Claire's talk into our methodology? Cool, so quite a number of you, that's great. So I'm not going to go over this in too much detail, but just for those people that weren't there, just a quick overview. So we developed a search strategy, I say the royal we, Claire and my colleague Sonia developed the search strategy, which then fed into the search results. We pop these into VOS Viewer. I know a number of you will be familiar with this, and I'll be showing some images of VOS in forthcoming slides. These then developed some keywords and also some excludes, and we use these to group and to create a thesaurus. And the thesaurus was particularly helpful because it allowed us to do things like deal with, for example, Americanized spellings, and if there was pluralizations, that kind of thing. So it allowed us to group and not, for example, separate like liver and liver cells. That was all grouped under one. So keywords weren't double counted effectively. So this is VOS Viewer, this thing on the left, and what this allowed us to do was to visualize the most frequent, that's that blue dot at the top, and the newest keywords at the bottom here. And again, I'll show you some real-world examples of those in the forthcoming slides. We took those keywords and we underwent searches in places like ct.gov and embase open brackets obid close bracket to find applications of these keywords. And we assessed unmet needs, and we defined these as drivers for development, so for example, diseases or conditions. And we also had a look at the TRLs, technology readiness levels, and I'm sure you all know what they are, but that's a standardized 1 to 9 scale to assess the maturity of a technology. So moving on to the main bit of it, the results, what we found. So just again to flash up this particular curve, we were taking the most frequent, the blue dot at the top, and the newest keywords, the orange line at the bottom. Who wants to see an application of this in actual practice? This is what it really looked like. Ta-da! So blue one's at the top, and that's an actual trend line that we took. So that's exciting. It looked like we thought we was going to. Hooray, the science works. So the 3 newest ones that we found at the top were hydrogel, scaffold, nanofabrication. And just to show that we weren't lying, this is VOS Viewer. So this is, if you remember Claire's talk from earlier on, this is the cleaned map once it had gone through the thesaurus. And the circles here basically represent the frequency of the keyword. So the bigger the circle, the more times that keyword appears. So as you can see, far and away the biggest one here, hydrogel. And it's not quite so obvious, but this was followed by scaffold and nanofabrication thusly. So you can see there that those are the biggest ones. So let's have a look now at some applications. So we had a look at the TRLs for various reasons. We could only get the TRLs for hydrogel and scaffolds, and those were between 6 to 7, so that indicated they were relatively mature. So for hydrogel, we found that you could use it to make heart tissue with vascularization potential for transplantation. And I thought that was really cool because that ties in very much to the conference's theme of equity and equality, because as we know, the demand for hearts far outstrips the supply of donors. So if you can make heart tissue that's basically ready beating and put it into a patient, because obviously it's very much that simple, that has great implications, because if you can improve the supply, and that has implications for inequity and inequality. So I thought that was really cool. Right, one more hands up. Who has had a root canal? Yeah, best way to spend your Thursday afternoon, right? So you can bioengineer dental pulp, and that helps with the healing after a root canal. So benefit for next time you have one. Scaffold then is our next one. So, and again, this is probably my favourite one. I absolutely love this ear. You can bioengineer an external ear using a cartilage xenograft in a 3D printed scaffold, and I think that was really cool. Basically, it's grow an ear. And in a similar fashion, you can use a cryogel scaffold for diabetic foot ulcers. And for our final one, nanofabrication, you can use it in novel machine-brain interfaces. And also you can 3D print calcium phosphate structures like vertebrate bones and teeth. So if you believe in the tooth fairy, you're very much quids in if you can 3D print your own teeth. So let's have a look now at the lowest number but the newest keywords. And there are 4 here because 2 of them have the same date. So we thought, why not? Might as well have a look at those. And these were microfluidic, a word I shall pronounce very carefully with a soft C and call it fusoidin, electrodeposition and transistor. Let's have a look at some of the applications of these. So first of all, microfluidic. I think that's beautiful. I think that's a really beautiful diagram that I've taken from a paper. Basically, this is a growing neuron. And if you grow them in certain homogeneous substrates, they can basically have quite too much synchronized activity, and that can mask the consequences of an external substance. So basically, it's masking the real effect that you'll find you're getting artifact in there. And you can suppress that by using microfluidic devices to grow the neurons, which then show actual detectable modulation and neural correlation. So basically, they act like neurons should do if you grow them in a microfluidic device. Next up, fusoidin. I had no idea what this was, so I had to go and Google that as soon as I saw that as one of my keywords. It's a water-soluble sulfated polysaccharide. It's basically a structural sugar, and they're found in seaweed. And as an aside, seaweed, as I also found out, is a really good carbon dioxide sink. So it's got really good implications for net zero and decarbonification and that kind of thing. So if this takes off as a treatment, it's also got environmental impacts, which I thought was really cool. Interestingly, some cancer treatments work or improve the efficiency if you can oxygenate them. So if you can get these microalgae to photosynthesize at the site, there are certain cancer treatments like radiation therapy, photodynamic therapy, and you can really improve the effectiveness of them if you put oxygen in the right places. So huge implications for cancer therapy. Next up, electrodeposition. So if you can electrodeposit antibacterial silver particles onto prostheses, this has a very high antibacterial rate against things like E. coli and also really good biocompatibility. So basically, if you put a prosthesis into a patient, there's less likelihood of getting infections at that particular site. And last but not least, this funky glove-looking device, which is an application of a transistor. So basically, it's a tactile sensing device, and again, particularly useful in rehabilitation. So those are some of our applications. Moving on quickly now to implementation requirements. So for hydrogel, we found that it's the absolute cornerstone of bioengineering. It's used in so many different applications, but they could do some more studies into collagen and extracellular matrix, especially for cancer. We actually found just one product on the market for cancer. For scaffold, again, absolutely fundamental to bioengineering, but there weren't that many trials into the unmet needs. Nanofabrication, used a lot in biosensors, we've just seen, but there were a huge amount of applications there. Fusoidin, huge potentially in therapeutic bioengineering, but the use here relatively limited. And electrodeposition, as we've just seen from the prosthesis, great applications here in the orthopedic implants and scaffolds. And finally, transistors, relatively early stage, but it is a field with quite a lot of potential. So for the technologies at a higher TRL, 7 to 8, it's really important that, and I know it sounds obvious, but make sure there are adequate regulatory and approval processes, and there is the expertise there to be able to assess them. Because it's all very well and good having these really cool tech, but unless you can assess it and approve it, it's not going to get into the patients. So finally, next steps, and this is hot off the press, is something I'm working on pretty much right now, and I'll be going back up to the office to work on this after this particular talk. So, PESTLE framework, I'm sure everyone's heard of that, but can anyone shout out one of the names of what makes up the PESTLE framework? And there's a reward of a wagon wheel for anyone that's brave enough to do so. There we go. Who is that? There we go. Catch. 3, 1, 2, 3. There we go. Nice one, thank you. So yes, so this is a framework of political, economic, sociological or social, technological, legal and environmental factors that provide the context for what it is that you're trying to get into practice. And we're going to effectively do an evidence gap map of recent policy documents. I mentioned the 10-year health plan. I think everyone's mentioned the 10-year health plan today. And there's also a document from April earlier on this year, Engineering Biology Aspirations, National Vision for Engineering Biology, and also the DCIT Science and Technology Framework, which is now a couple of years old, but we think still relevant. So basically, having a look through that and see what we can find. So basically, watch this literal space. So that just remains for me to thank my amazing team. Couldn't have done it without these guys. They've just been fabulous. Really looking forward to seeing what we can do next. Very happy to now take some questions. Otherwise, I'm just going to stand here for the next 3 minutes. So. Or does everybody just want to go home? Yes. Let me get my steps up.
That was a fantastic talk. Thank you so much. I just wanted to know if you'd looked into any sort of the equity considerations. You mentioned them several times. Some of those technologies you identified as well were in those late-stage TRLs. Have developers been building in equity considerations into their research, or is that an unmet need you think needs to be addressed?
I mean, some of them will just naturally just address things like, hello. Some of these will naturally address unmet needs, for example, the access to donor hearts, that kind of thing. We didn't specifically look at that, so genuinely I couldn't particularly tell you if some are more equitable than others, which I appreciate is probably an unmet need. So if we do take this further and do take some of these and have a look at it into more detail, that's definitely something we'd look at. But I think by the very nature of this, we are improving equitable access because we're in some of these, I say we, again, the royal we, there is simply more of them being generated. So yeah, that would probably be my best answer to that one. We have 1 more minute. Anybody wants to ask something else? Cool. In that case, I shall exit screen right.
Thank you very much, Pauline. Oh, good gracious, I need to clear my throat. So, that brings us to the final talk of the conference. Everyone, please give a big round of applause for, again, another one of the IO's own, Megan Fairweather. Start clapping to her.
So hi everyone. So I'm going to be introducing you to another arm of the Game Changing Tech project. So this one is a horizon scan of wearable devices used in healthcare. Right, so now a quick introduction into the types of wearables that exist. So you may first of all think of things like your Fitbits and your Apple Watches, anything that like tracks activity, but there are loads of different types of wearables. So these are things like belts, patches, plasters, and then anything that goes in your ears are actually called earables, which I think is a funky kind of name. And then eyewear, so glasses, goggles, or VR headsets. And then smart clothing, so this is like any sort of clothing really. There are smart jackets, smart vests, smart socks and shoes. Everything can be made smart, apparently. So there are some wearables that are approved at the moment and used in the medical field. So you might be familiar with these. The one on the right is a patch that's used to measure blood sugar in patients with type 1 diabetes. So yeah, these sort of wearable devices that have already been approved are really good at managing health conditions, but also just increasing patient independence overall. So the aim of our project was to identify novel and potentially game-changing wearable tech for healthcare in the UK, which can help prevent, diagnose, prognose, and treat a variety of conditions, diseases, impairments, and disabilities. So there's actually 3 arms of our project, so 3 different categories. So the first one was remote patient monitoring. So these are devices that capture a vital sign. So these are things like heart rate or temperature. And the important thing about this category is that the data is then sent to someone else, usually a medical professional. So the data is collected remotely, basically. Our second category was chronic disease management. So these are devices that control, manage, or monitor symptoms. And then our third category was rehabilitation. So these devices improve the status of a condition and can improve outcome measures. So now on to our methodology. So first of all, where did we search? We used few different kind of databases, so bibliographic, trial, pattern, and funding. And after the first search, we had a grand total of 5,125 records that we then had to screen through. So yeah, we were quite worried about this, but really, luckily, we had the help from one of our colleagues, Lena. She's developed an LLM which is able to semi-automate the screening for us. So basically, to kind of put this in a shorter way, we dual screened a 10% pilot sample, and we used this to be able to develop prompts for the LLM, and then we gave the LLM all of the records. Because we designed the LLM to be overly inclusive, we had to manually screen 100% of its includes, but only 10% of its excludes. So this reduced the number of records we had to manually screen to 3,674. So this is what we ended up with. This is the total number of records. As you can see there, rehab is pending because it's still a little bit of data analysis ongoing. So I'm mostly going to be talking about these 2 categories in the presentation. As you can see, chronic disease management has a lot more records than remote monitoring of vital signs, especially when it comes to the bibliographic records. Next step, data extraction. And lucky, again, we had help from Lena, another large language model. This one was able to semi-automate data extraction for us. So basically, it gave us 2 outputs. So the one at the bottom here is a spreadsheet, and it's basically extracted all the data and put it in the spreadsheet, like for each item. And then it also gave us an output, which you can see at the top there, and that is a highlighted abstract, so we could then go and see exactly where it got its data from. And we could use these together to go through and check all the LLM's answers and make sure everything was correct, change anything that wasn't. So kind of what we were talking about earlier on the panel, where we trying to use humans and AI together to make sure we're increasing efficiency without decreasing accuracy. And then we really wanted to include some patient and public involvement in this. And this is because when you look at these wearable devices, you soon realize that a lot of them aren't actually designed with the patient in mind. And so obviously this can become a really big problem. So we wanted to create a patient preference checklist to help during the evaluation and development of these wearable technologies. So the way we did this is we had 2 patient advisory meetings, and we asked them questions like, what would you look for in a wearable? And we also gave them a few example technologies and asked for their opinions, whether they were negative or positive. So moving on to the results. Just to note, this is just the bibliographic results to kind of keep it a bit simpler to show. I understand there's a lot on this slide, a lot of information, but I thought it was quite nice to show the spread of data using technology radar. So if you're not familiar, it's basically the further from the center of the radar the technology is, or the circles are, the further along the developmental pipeline they are. So technology readiness level 9 are devices that are already approved and being used on the market. So the first radar is remote monitoring of vital signs. So this is in terms of disease areas, and you can see a lot of the technologies kind of lie in the middle of the development pipeline. A lot of them just started clinical trials. And for disease areas, there was a lot of technologies that hadn't really reported their disease area Whether this is just because it was remote monitoring, it was for general kind of health monitoring. But compared to chronic disease management, which is the second radar, there was a lot bigger variation in disease areas. There was a lot of technologies that were looking at neurological conditions, as well as musculoskeletal conditions and cardiovascular conditions. So these are some radars again, but this time it was looking at different types of wearables. So for remote monitoring of vital signs, patches were kind of common, whereas for chronic disease management, again, we were seeing a bigger variation. So new, like different types of technologies were coming through, like VR headsets and implants. And now moving on just to a few examples I picked out just to so you kind of get an idea of the different types of technologies out there. So this is a biosensor patch which is able to detect inflammatory marker C-reactive protein in sweat in patients with COPD. These are some rather interesting looking goggles. They're able to track facial expression, and so this paper was looking to see if they have kind of an application in mental health. And this device integrates EMG and a microphone to detect swallowing disorders in patients with stroke, Parkinson's, and head and neck cancer, because these groups are at higher risk of choking. And this is the outcome from our patient advisory group meeting. So we did create our patient preference checklist, and I'm not going to go through every one of these points, but just a few highlights. The patient advisory group were really keen that any device should really provide data that is useful to the patient and doesn't just cause unnecessary panic for no reason. So it's fair enough, yeah, you get given data, but what are you going to do with it? Is there an outcome from that? Can you use the data to do something positive? They also wanted to know where's the data going? Well, how is it being stored? So privacy was a big issue there. Will this technology be accessible for all who need it? And this is in terms of not just cost, but for things like how tech-savvy the patient is, or if they've got internet access. Also, is the technology visible and what does it look like? Some groups of people do not want others to know that they have a diagnosis, so this could be a big issue. And of course, is the device comfortable? But this is also for different situations, like if you need to wear the device during sleep. This is more important. So to conclude, we created a list of emerging wearable health technologies. We identified trends, gaps, and barriers within this landscape. And we created a patient preference checklist to help with the development of this wearable tech and also for the evaluation of wearable tech that already exists. And the reports will soon be available on the IO website. So there's 3 reports, 1 for each category. They're not there yet, but this is a QR code for the report section of the IO website. So basically, just keep an eye on it. So I'd like to thank my team, as well as our stakeholders, the Department of Health and Social Care, and of course the NIHR-IO Public Advisory Group, or Patient Advisory Group. Thank you.
Any questions from Meg?
Yeah, thank you for an excellent talk. It's a great way to cap off the meeting, I'm sure. So I was wondering, you showed these nice overviews and you determined the TRL level. How did you manage to do that, to determine for all these wearables what the TRL level is?
We basically went through, we didn't actually have the LLMs help with this one because we kind of thought this is something that we need to look more into. It's quite important. But yeah, we basically went through and used the abstracts because we decided, we had so many records, we can't go into the full text for everything. And we, obviously, if it's at a clinical, it's described in a clinical trial, that's kind of easier, and we can put it at like 5 and 6, or 6 and 7. If they were kind of studied, not at prototype stage yet, we could put them in certain, but we had a set of kind of guidelines which described each technology readiness level, and we kind of just went through a few of them together, kind of talked to each other and decided based on that way. Also, if the technology had a name within the abstract, we did separate searches on this so we could find more information, say, from the company's website. Yes, it took a while. Yeah, it did take a while.